Hello, hello, hello to everyone. Thank you all for joining our room. And let me first introduce myself. I'm Daria. I will be your host. I'm playing the role of data and analytics consultant, and also I'm a head of BIA discipline at EPAM globally. So today we are here in this room to discuss most hot topics related to data and vision and strategy. We will have multiple speakers who will tell us about different domains and different tools in this area. And first of all, let me invite our first speaker. It will be Kanstantsin, who will tell us about AI tools and their impact on productivity, both positive and negative. So, Konstantin, I am pleased to welcome you, and let's start.
Hey colleagues, as already mentioned, I'm Kanstantsin Karneliuk, and what I'm doing at the PAM, I'm delivery manager, basically delivery director, and also I'm co-owner of several AI initiatives related to productivity. So let's have some fun. Yeah, so my topic is called advantage or interruption for productivity, but basically you can see it's AI for productivity. And as Daria mentioned, we will discuss various impact of the tools and approaches to what you can gain or what you can lose. A couple facts about me. I'm more than 18 years in production IT, of which more than 10 years I was working as pure software engineer, like team leader, tech leader, and then more than 8 years as a delivery manager. And as mentioned, co-owner of some initiatives, and will mention some briefly. What we'll be talking about today. So first of all, we'll look a little bit into the history and evolution of AI. Then we'll talk about main considerations when talking about productivity, and then focus a little bit on scenarios specifically for IT. Also, I'll mention some results that I believe are amazing across all industries, and at the second half of our talk, we'll have deeper dive into ways how to still get advantages using AI tool for your productivity, and the reasons why you may get it instead of advantages, you may get some interruptions or slow down. And at the end, you'll have time for your questions. Okay, so you all hear that fancy tools and fancy words as AI, LLM, self-driving cars. So all of them are emerging in the recent years and look like it is a really new technology. But how new are they in fact? Let's take a look back and see. And we'll start from the bare metal scenes. So you know that nowadays, especially who are like automotive enthusiasts, you know that nowadays we are speaking about those Tesla autopilot. Almost all car makers have their own autopilot or copilot features. Also, those robot delivery by Amazon, like robotaxi, autonomous taxi by Uber, and things like that. But in fact, almost 100 years back, there was implemented and launched wireless, or if you want, radio control vehicle that was driven in New York City, basically in urban area, and it was called as American Wonder. So just think about it. Almost 100 years back, we already had it implemented and launched. Definitely, it's not compatible to the level we have right now, but definitely it was another level of technology. So the idea and its implementation is pretty mature. After that, there was many different investigations, many different researches, and next interesting fact it was that in 1960 at Ohio State University there was a project about building the whole infrastructure. So team took a different approach and they tried not to make the car autonomous, but also to build infrastructure that the car will be autonomous. They finished their researches and prototypes by 1966, and based on the results, they were saying that in next 15 years it can be the system that I mean the cars and the surroundings can be launched publicly in next 15 years. But then in 1970, with the development of the technologies, researchers realized that building the whole infrastructure might be quite challenging and quite heavy on funds and investments, and they focused on building the cars that will be more autonomous and will not depend on the surroundings. And it resulted that in 1995 there was a race they called No Hands Across America. It the distance was about 3,000 miles, which is more than 500, about 500 kilometers, and 98% of this distance, car was executed in completely autonomous mode. So it was on public roads. It was cross-country journey, meaning there were different conditions, different circumstances, but the car managed to do it. In the recent decades, the development get additional boost, and in 2004, the RPA, basically it's agency that supports researchers in emerging technologies, announced the challenge to run 150 kilometers in the desert in completely autonomous mode. And despite the price was quite high, it was $1 million, no team was successful. But already in the next year, in October 2005, there were 5 teams who could make this distance. And in this case, it was a little bit more challenging. So the car need not just to drive from point A to point B, but there were also several checkpoints in the desert that car must visit during its ride. And in November 2007, the challenge was already submitted in urban area. Definitely, there was some preparation to make it as safe as possible, but again, several teams, several companies were able to construct the car that can completely autonomously drive in urban area for the specific distance following the specific route without accidents. All of that rapid development led to that in October 2010, in fact, most of the usage of such vehicles was banned. So yeah, it stated here that there was a concern raised, but the concerns was raised in the form that the car must be controlled by human. Yeah, so in fact, banning all the public usages. And what's happening now? Are the cars on street or not? As you see, it's not. It's not because only in 2019, some of the usages, some of the states started permitting any kind of automation and autonomous driving in the streets. And in 2020, European Commission also allowed automation of level 3. Automation level 3 means that some of the features in some conditions can be automated. For example, like the car keeping line on highway, but still the driver must present in driver's seat and is responsible to control the automation, how it behaves. And only in April 2023, in Japan, there was a public act that allows usage of cars with autonomous automation level 4. Automation level 4, it means that in some conditions the car can be executed absolutely autonomously. Meaning, for example, that on highway, when the weather is fine, the car can be executed without any expectations for driver intervention. Just think about that. The technology itself was first launched almost 100 years back, and only nowadays we see how it is being admitted into use in public. So, what's about not bare metal, but more virtual things as AI? Here, the story is not so long, but also quite amazing. As a discipline, AI was announced in 1956. And in 1967, ELSA, the first chatterbot, passed Turing test. What does it mean? So Turing test is conducted in the following way. A human being communicates via chat to several counterparts. One of this counterpart is a computer system and others are humans. And that if the person who is communicating cannot for sure say who is talking to right now, is it a piece of software, or is it a real human, test considered to be passed. So just think about it. Yeah, it's 1967. It's quite long ago. In 1980, XCON, which stands for Expert Configuration, an expert system was implemented and executed in a DSC company. It is a company that was responsible for trading spare parts for computer, like cables, motherboards, stuff like that, and also applications. And at that time, with introduction of this system, they were saving up to 40 millions a year. But just think, it's 1980. So if convert to nowadays, the amount of saving is much, much, much higher. And neural networks that are also emerging right now, and that believes to be quite modern. Most of the researches that they are based on were done in 1980s. In 1989, Deep Thought, a chess playing game with outstanding results, was executed. By outstanding results, here it meant that it won several grandmasters, but definitely it was defeated by Garry Kasparov. However, companies continued investigation an improvement of the algorithm and of the compute power, and in 1997 the blue won Garry Kasparov, who was absolutely a world champion at that time. In 2011, IBM's Watson system defeated Jeopardy champions. So Jeopardy is a quiz game that is quite popular on American TV, but it uses not standard approach when the players are produced with questions and they need to provide an answer it. The Jeopardy uses a reverse approach. So basically, you are provided with some facts about the place of the person, and then what you need to provide as answer, in fact, question that answer to that is related to the facts you were provided. And starting 2018, there is emergence of LLMs. So we'll talk about LLMs a bit more later in details. So just why everyone is talking about AI right now then? And this Gartner hype cycle explains it. So what is this hype cycle at all? So it is explaining how any perspective technology emerges. So in the beginning, there is innovation trigger, and nobody is aware of the technology. Then there is peak of inflated expectations. When people start experimenting with the technology and get some results, those results are communicated. More and more players start exploring the options. That's why there is a hype, and actually it's what you see right now. Yeah, that robots will replace human, AI will replace specialists, AI will replace QA or developers or whoever. So that's why currently we at this hype. But if you look in a bit more details on that slide, real output and productivity plateau, meaning the state when everyone understands what the technology can afford and what the technology allows to achieve and what's not allows to achieve, it will be in 2 to 5 years. And that introduces very strong competitive advantages. And as you know, currently this area is kind of a little bit gray from perspective of intellectual property, from perspective of laws, and companies are working now on policies how to use AI, and also governments are using on laws. And you probably know about, we have those European drafts for ethical AI, and each and every country is also involved into building laws regulating the usage of AI. So, but what we can learn from this history of self-driving cars, it's not just I mentioned it for fun. We'll know that earlier or later those regulations will be done, and we will have all the legal fields to deal with AI and AI-based tools. Also, we know we see that AI introduce much more unknowns that are introduced by bare metal cars. Yeah, and the more people explore it, the more usages and the more outcomes we get. That's why it's a good time to start your journey right now. Also, we know that the tools are evolving super fast, and some of the results that are not achieved by previous generation of the models can be achieved by new generation of the models. Also, we know that based on this Gartner hype cycle, that companies will know how to adopt many of those technologies in 2 to 5 years. So basically, the companies that will adopt technology in 2 years will have very strong competitive advantages compared to the companies that will adopt in 5 years. That's why there are companies and communities and businesses that are ready to take risk of dealing with not clearly regulated technology. And definitely, business wants productivity boost at price of couple cups of coffee. So if you think, for example, about Copilot, for which we have pretty solid statistical data that shows how it interferes and how it improves productivity of the developers, it costs $20 a month. So in fact, it's just literally a couple cups of coffee in order to improve the performance to 30-50% in depending on the use case. So definitely that proves the usage of the tools is inevitable, and we need just to know how to use it, how to adopt it. So let's talk a little bit about what we need to consider when talking about AI for productivity. So first of all, let's introduce several definitions. So AI, by AI we mean the tools or technologies that mimic human behavior. Basically, like they mimic decision making, they mimic logic and fuzzy logic, they mimic like basically generation of new content, like songs and or text. And also one of the characteristics of such tools and programs is the fact that they can evolve without source code being changed. If you think about how neural networks are working, yeah, you implement it, you have codified it, then you just produce different input to teach it, and based on the input you produce, you change the behavior of the network, yeah, without touching the code. Gen AI or generative AI. So those are tools that are focused on basically generating new content. It may be video, it might be audio, it might be pictures, it might be some text. And by generation here, we mean not just creating from scratch, but sometimes just refactoring, rewriting, summarizing, and similar activities. But still, it's producing something new. LLMs, large language models, this is development of NLP approaches, natural language processing models, and there are several characteristics of them. First, they are going pre-trained at a very large data set. And second, you can change their behavior by prompt engineering. So in fact, by setting them how to behave, you change the output that will be produced. And productivity itself. So by productivity, we understand the intersection of all those three circles. That is quantity, effectiveness, and quality. So it means that if you can complete lots of tasks with little effort and the work that was produced is of good quality, only in this case we can talk about productivity and productivity increase. If you can complete bunch of tasks with little effort, but the quality is not good and you need to invest additional resources in changing this quality, then we cannot talk about productivity burst. And what are the main challenges that we face when dealing with AI in general and trying to adopt AI for productivity? So first of all, as already mentioned, laws and policies. And the tricky thing here is for large cross-national organization, because in some cases policies of the company will be stricter than local laws, and in some cases laws of the local country will be stricter than policies. So when adopting company-wide technologies, it is a very severe point to be taken into consideration. Second is complexity of the industries. So different industries have different complexity and also have different level of maturity. So we were speaking about LLMs, and for example, ChatGPT is in fact is some additional software on top of LLM. As we mentioned, it goes pre-trained, and depending on the information available for during this training of the model, the results will be different for very different industries. That's why it's almost impossible to take the results from one industry or from one business domain and transfer them to another business domain and achieve the same level of success, or vice versa, the same level of failure. So there will be different considerations when adopting the tools in different business domains. Also, what is important to consider, and it goes as challenge, is dependencies between roles, teams, and companies. Even working to the same client, there might be different vendors with different policies and different permissions of use one or another tools. And also, if you think about team and end-to-end process, even improving, maybe significantly improving performance of one or another team member or team roles, it's still on end-to-end basis may not have noticeable impact. Another challenge is that tools evolve quite fast. That's why you need always invest in R&D and L&D. Otherwise, you'll get not so good results and will be out of business quite fast. For example, you may heard that there was OpenAI Dev Days recently, and where many new features were announced, and previously companies tried to build some of those features on their own on top of LLM, and now they are available out of the box. We definitely providing better quality than many of the attempts that companies used to create on their own. Tools hallucination. As mentioned, AI mimics people, and people sometimes have bad days when the output is not relevant or looks quite challenging, quite strange. The same is produced by tools. Yeah, they can hallucinate just because it is like the way how they are built. So you need to take it into account when trying to adopt the usage of the tools. Results are hard to reproduce at multiple runs. If you played with ChatGPT and set temperature above 0.1, you can notice that in subsequent calls, even with the same input, you may get quite different output. Yeah, just because the nature of the tools again. Another thing is that as we're currently in hype, in this in hype pike, I mean, peak of inflations, there is large overestimating of what tools can do and what tools cannot do. So you need to do a diligent testing before investing significant amount of money in adopting the tools. And probably the most important, that is why it's put last, the tools work on seniority in, seniority out basis. So you clearly need to understand how the tool is working, what you want to achieve as a result, and you need to get good knowledge of your subject matter to be able to understand why the result is not adequate while it looks like adequate. Especially, for example, you may do the very basic test and try to play with ChatGPT, asking to generate some tangible SQL code for quite complex query. In most cases, you will get something that looks like SQL, but still requires manual polishing in order to be executed. Let's spend a couple more minutes trying to understand where those legal issues come from. So first of all, those models were trained at publicly available information, but we cannot be 100% sure if all the copyrights and licenses requirements were met during the training, and also if they have not changed over the past. Second is that when you provide it with some output, you cannot say for sure, is it a quote from some copyrighted item or was it created by the tool itself? And if it's created by the tool itself, who is owner of this intellectual property? Is it you because you provided such input to the model? Is it the model owner? Is it the company that provides infrastructure? Or is it the author whose content was used for pre-training the model? So in order to be on the safe side, definitely it's something that is now being discussed, and you know that Copilot constantly changing their license and Microsoft changing their commitment in order to put everyone on the safe side, but still it's a little bit of a gray zone. And in some cases, in order to be sure that the intellectual property belongs to you, you need to rewrite the output generated by LLM. But in this case, we cannot talk about the productivity, right? Because you need to invest additional efforts in recreating the result you was provided. And also, as already mentioned, different countries work on regulations. There will be completely different regulations for using LLMs in particular, and AI-based tool, and you will need to constantly monitor the situation, how it goes with your customer and how it goes with your country, because definitely we expect a bunch of surprises here. But if to speak about the scenarios, I mean general scenarios, not related to IT, that may be interesting for improving your productivity and for playing with AI-based tool. So first of all, it is very good for interview preparation and interview simulation. Because even with help of ChatGPT, you can create the prompts that will teach him and ask him to behave as interviewer, and then you will be provided with the questions, you will provide it with you will provide answers, you will provide with the final results and assessments, and this field of application is quite good documented, so there are a bunch of examples here. Also, it is good for CV preparation because it's extremely good in LLMs are extremely good at providing a summary for different text. Also, it's very good in providing well-versed English, mostly English, but other languages work as well. So it provides much better results than just using straightforward translation tools. Subject matter explanation. Again, if you want to better understand about some subject matter, that LLMs and ChatGPT can help you a lot. Explaining about like main terms, how they interconnected. Definitely you can achieve the same results like just Googling, but in this case you will spend additional efforts. Finding trying to use different links and then like copying the terms, and you will end up with a bunch of tabs in your browser and just trying to switch between them instead of having well-looking dialog. Project onboarding. Also, it is a very perspective field where AI tools can be applied, because like how project onboarding might look like. Yeah, typically you have a bunch of links on knowledge base, bunch of instructions, some emails, some code snippets, and if you use smart search, if you use summarization, if you can fill all this data in some LLM, it will be easier to do onboarding, just because you will have Q&A. You can do Q&As, you can have good access to source information, and also to get summary of what needs to be done, what it is all about, and what rules you need to follow. Similar things for L1 support, because L1 support typically deals with the tasks that are quite trivial and that are there in work instructions, but for some reason people are not working, looking or not reading them. And having chatbot, we have examples where those chatbot literally provide very good results automating this work. And definitely summarization, notes preparation, summary preparation, it is something where we really recommend to use the AI-based tools, because the results and the quality is very good of the output. Let's look a little bit into scenarios that are possible in IT and for different roles. For example, for solution architect, we know that it is very good for requirements instruction and gathering, as well as dealing with quality attributes, prioritizations, collecting some baselines. There are prompts that really introduce performance boost on these tasks. Diagrams generation. Here situation is a little bit different. So the tools can definitely generate the architecture diagrams you need, but here results are very debatable. And it is a good field to explore here, because in some cases the results were acceptable, but in some cases, and I would say even in most cases, to time that was spent on editing the results provided was much more than drawing it with hands from the very beginning. Domain-specific best practices advisory. Again, if you're new to some business domain, ChatGPT or some other LLMs in most cases will be very effective to help you on board and get the main knowledge, the main best practices, and the main things to do and not to do. Slide decks generation. Yeah, it can generate the structure, it can generate the content. And for example, if talking about this slide deck, all the pictures here except my photo and Gartner diagram are results of using generative AI. For project managers, again, it is about slide deck generation, like meeting summary generation, especially if you have especially when you have transcript. It is just amazing to collect all the notes and make sure that nothing important is missed. Again, onboarding to subject matter, and what also we are using LLMs for contracts review. It is connected to best practices and recommendation, because it highlights the things that are mentioned there in contracts. It can help you to summarize the risks. It can help you to make sure that the contract has all the necessary chapters that must be there. So like pretty good kind of copilot. Definitely not self-sufficient. But to help project manager be more effective, it is during those contracts review, it's nice and to try. Knowledge transfer preparation, again, it helps with the plan, it helps with the topic, and also generating content for the knowledge transfers. Project and resource plan recommendation validation. Well, here is a funny thing. We played with it at different levels, and then at the end of the day, we were able to achieve some positive results. But when we started to just blindly started to use LLM for creating project plan, provided the context to ChatGPT, and also provided several limitations. One of the limitations was like, hey, it must be for people team, yeah, trying to see how it will manage timeline when the number of resources is limited. And what ChatGPT did, in fact, there were 6 or 7 roles suggested by ChatGPT, but simultaneously only 4 persons were working. So, I mean, it was a nice joke by the tool, I believe. So for business analyst, again, requirements extraction from the documents, from the meeting notes, and creating them in well-written English. Slide deck generation is already was mentioned, summary generation, and also there are prompts that, based on the requirements, help you to create well-written task description ready for Jira, taking into account also suggesting some acceptance criteria or definitions done. So really improves the work of analysts. For software engineers, code generation, Copilot, not much to tell about it. Automatic prototyping, again, you can talk to either to general purpose models like ChatGPT or to some code llama and about the needs of prototype, and you will get skeleton of code that you can then reuse and enhance. Code explanation, again, it provides pretty good results when explaining about the logic that is provided in the piece of code and code rewrite. Actually, one of the initiatives where I'm co-owner here at EPAM is building a tool that will automate routine work of transferring code from technology A to technology B. At the moment, we are not talking about re-architecture and re-engineering, but just about code rewrite. So how it works, you provide the code in language A, saying in like what technology you need this code to be written to, and get the code. Definitely, it requires some polishing. Definitely, then it requires some re-architecture or proper packaging. But still, on routine tasks, we achieve up to 50% of the performance improvement. Test generation. Again, those tools are extremely good for unit test generation. There is a bunch of best practices that you can use. For DevOps, again, it's about code on infrastructure explanation and pipelines generation. Here again, we have debatable results, meaning for build pipelines generation, the results are like much better than if you try to generate again end-to-end infrastructure. Yeah, so it's good with providing what our experiments demonstrated. It's good in providing some pieces of infrastructure as a code, but if you want to ask the tool to generate the whole infrastructure, well, sometimes it requires too much of polishing, but definitely tools evolve and we'll repeat the experiments later. For quality engineers, again, it's good for test generation, it's code generation for automation tests, and also for advisory on test strategy, just to make sure that you're not missing any essential parts. And so the quality of work dramatically improves here. As promise, just want to mention some results I believe really outstanding, and one of the results it was in 2022 about quantum physics field of science. Yeah, there were using those AI-based tools. There was attempt to optimize the prediction of electrons interaction. Yeah, I mean, where they appear after the interaction. And previously, scientists used to solve about 100 of thousands of quantum equations, but after that optimization, now they need just to do 4 of such to solve just 4 equations, and the prediction rate is the same, so there is no changes in the output of the quality. And another very interesting experiment, it was held last year and partially this year in emergency department. They used ChatGPT for providing diagnostics to the patients, and they get approximately the same rate of accuracy as dealing with humans. I mean that that the diagnosis that was done in emergency appeared true after additional examination when the person was already in hospital. So it's pretty positive results, as definitely tools required much less time than humans to set this diagnosis. Yeah, what you need to think about when if you want to achieve advantages in with those tools of productivity. Just to remind what we call productivity. It's many of tasks with less effort and good quality. So you need, first of all, you need to think how to split the task you're working on into smaller chunks of work. And second, you need to make sure that you're not missing any chunks of work that are there by default in your mind, or that you're not combining them, that the work is atomic as it can be. Also, you should think about if the new process may be introduced. I mean, if some of the chunks do in fact doing the same and can be combined or can be executed in different way. And see what is easy to automate and automate it. In order to about efficiency like considerations, first of all, do not try to automate everything, because in many cases, time and resources spent on automation will be much higher than benefit you will get at the end of the day. Also, do not focus on automating only most complex tasks. In some cases, automating routine tasks brings more value than and brings result faster than automating just complex things. Also, make sure that you are testing different tools and testing different approaches for the task solving, because again, seeing that it will be machine solving the task, not human, so it might be possible to find another solution, yeah, which is more relevant for machine, because it doesn't have human limitations. And also, in order to measure if the solution is efficient or not, consider the time that is required to adopt the results or check that the quality is good. And also always take into account end processes. Sometimes, again, you will waste time on automating some certain steps, but other steps will become bottleneck, and no impact will be in the end-to-end process. In order to have a good quality when using those AI tools, so always try that results are repeatable, and do as much testing as you can. Here it is vital, because sometimes you will get very unpredicted results even with quite straightforward input. Also, make sure that there is a good knowledge base inside your organization where the results are shared, because if the same things are done differently in different departments, the results will be quite different, meaning that efficiency of the whole organization and the quality of the whole organization will be unpredictable. Also, you check if you can use you can combine several prompts, or you can use several approaches in parallel to solve the task, and then to cross comparison of the results to make sure that the quality is good. And also make sure that end-to-end quality is will not suffer, yet that there are additional quality gates after those AI and LLM based tools, because, as I said, sometimes you will get surprises. And also, you need to make sure that the system you built based on AI tools have those explanation mechanisms, because again, it is a black box. In fact, it is a black box for you, especially if you're using when you're using pre-trained models. You don't understand why it behaves so out of the box. You need mechanism to understand it, and you need mechanism to have this feedback and be able to change your solution. What are the reasons why using those modern technologies you can get interruptions and slowdowns instead of gains? So first of all, you might start automating the existing flow, but as I mentioned, it is machine doing the job, so you might need just a completely new flow because a machine doesn't have human limitations. Also, think about the context, because if you try this ChatGPT, you see that when you're working in one session, sometimes it improves the quality of the results you get, sometimes it the quality suffers. So take into consideration how the tool is used. Also, most cases in enterprise, you will be in shared environment. Make sure there is no interference with other teams. Otherwise, you may just get stuck with this quantity of the things that can be run in parallel, and the number of tasks that can be run in parallel. So at the end of the day, you will have less tasks completed. Also, think about adopting the results into the process, because you are using new tool that will provide result in new format, and you might spend very large amount of time trying to adopt it. Also, think about the cases that improving one step may not help you to improve the end-to-end process. Be ready that different tools can be used on different steps for the very same process. Just keep in mind, just think about it. And also, the results are not repeatedly. Again, it's very hard to remember, but still the tool behave itself like this. With the same input, you may get different results. You need to validate as much as you can. You need to share the prompts to be ready for consistent quality within different departments of the organization, and also recall about hallucination. Yeah, so tool cannot provide the 100% accuracy, especially when you ask for for very specific syntaxes, and also sometimes tool follow very unexpected logic. So just to sum up, advantage or interruption, it depends on what are you doing and how much effort you're putting in testing. So tools evolve, new features appear, and tool itself is black box for you. Just recall, always think about it when adopting it. The same input doesn't guarantee you 100% the same output. Keep it in mind. The tools are trained at specific data sets. Sometimes you will need to have custom training. I mean, you will need model and fine tune it. Sometimes you just need to use prompts to tell the system how to behave, and definitely because of the data set especially for LLM is out of control, it is natural that it will show different results in different domains. The tools behave like humans. They will hallucinate, there will be bad days, and not everything should be automated. Again, when speaking about adopting AI, especially normally we use AI for automation. Just do not try to automate everything. Thank you. And could we go to the questions, please?
Hello. Yeah, hello again. Kanstantsin, thank you very much for interesting topic, for highlighting this. And guys, yeah, now we are coming to questions and answers section of our event. And just a reminder for you, for those who joined us via YouTube, you can find the links on our activities, on the quiz, on other streams in the chat. For those who joined via the VR community platform, you can find the same links in the comment section, in questions and answers section as well. And please, we ask you to ask the questions. It will help us to build our interaction in a better way. And thank you for those who already did that. So, Kanstantsin, we have a question. please, can you help us to understand what are the steps that are taken to address the data privacy concerns when implementing AI solutions in software development, particularly when dealing with sensitive user information? And while Kanstantsin is answering, guys, if you have more questions, please post them in the chat and we will try to highlight as well.
So it depends actually on the technology you use. So you know that some of the models can be deployed privately in your environment that prevents data leakage. Basically, it prevents, but you're in control of this data leakage. So you control who can access the model, who can execute the queries, and you control that the model doesn't share anything with the outer world. Also, if you're speaking about those, for example, OpenAI models that are deployed at Microsoft, during deployment, again, there are configuration that you need to take into account, which allows you to configure, do you want to use the input provided for this model to be shared with outer world, basically for with those models deployed globally at Microsoft, or everything must stay within your subscription. And also, if the data is provided, will it be used for model training, or it will be used just for providing the outputs? Yeah, so everything depends on the very specific case, and everything depends again on the data you are working with. Yeah, because definitely if so what I'm saying, so in some cases, in order to achieve the expected regulatory requirements and expected regulatory rules or company policies, you will be limited to using very specific tool, I mean, very specific model deployed at very specific region with a very specific configuration. So those are the main steps you need to take and the main questions you need to take into account.
Thank you, Konstantin, for answering. And we have more questions. And guys, thank you for active participation. Konstantin, what is our strategy in cleaning the data? Do we use only human or people hands and skills or any technology? What it costs to us? Please explain if you can.
So again, it depending on the use case, because if we're speaking about EPAM internal models, especially deployed via these DAL AI initiatives, as far as I recall, they are configured in the way that no data leakage is allowed, meaning that this cleaning, in some cases, it is necessary. Again, depending on the information we're talking. Yeah, I mean, the question is a bit in vacuum. So, but some of the information can be ingested into those models during development without any cleaning. Also, in some cases, we have we are working basically now on the accelerators that will automatically do some data anonymization. So it finds like company names, it finds like people name, and does anonymization of that stuff. But definitely human, as I mentioned, in sometimes those models provide quite unpredictable results. So definitely human validation after this tool is required.
Thank you, Kostya. So, human and our skills are still needed, even
Absolutely.
despite having such developed and powerful technology. Okay, guys. So, thank you very much for your questions, for your answers. We still have many activities prepared for you. Just kind reminder, you can go and check the quiz. Don't miss your opportunity to get some gifts from us. And also, we have many interesting topics ahead. And now we can probably switch and launch the video on the same. So
Thank you,
let's
colleagues.
watch it. Thank you, Kanstantsin.
Generative AI. We bring production-ready solutions to expedite clients in Gen AI transformation. We have Gen AI Innovation Hub, ready-to-use POC and accelerators and cross-functional team of experts to support our clients. Generative AI Virtual Tutor Assistant. EPAM Virtual Tutor is an Gen AI-powered L&D accelerator designed to provide a personalized learning experience to various groups of students via quizzes, flashcards, Socratic learning. Personalized Meta-Human Assistant. Virtual Assistant is a question and answer solution powered by LLM and conversational interfaces for a broad spectrum of tasks supported. Unlock the boundless potential of your business together with us. Contact us on epam.com. Computer Vision Solution is an end-to-end CV-powered products development from an idea to productization with diverse list of use cases. EPAM is ready to develop the variety of solutions from virtual try-on which redefines digital and retail experiences and customer behaviors. Two computer vision-powered AI merchandiser accelerator for CPG leaders to optimize store-level sales performance and enhance operational efficiency, as well as an advanced recommendation system for the fashion industry that takes into account both traditional information about customer preferences and the customer's sense of fashion by analyzing the visuals of products that arouse consumer interest. Unlock the boundless potential of your business together with us. Contact us on epam.com.
Hello again. So we are continue our journey via the AI world and modern data technologies. And guys, I'm not getting tired of reminding you that we have activities and we encourage you to participate in them. Please check the chat, check the comments, and you can participate in quiz and ask the questions during the talks, and you will get some gifts from us at the end of the event. And now I'm pleased to introduce our next speaker. This is Jonathan, our director in data and analytics consulting. Welcome, Jonathan. And we have another interesting topic. It's operational management of large language models in production, what it costs and what it takes to get AI products to market. So, Jonathan, passing word to you.
All right. Can everybody hear me? I'm assuming everything's good. Okay, cool. Everybody can see my screen. Good morning, good afternoon, good evening to everyone. Daria was mentioning, my name is Jonathan Rioux. Today, I think there was a little bit of a mix-up in the description of the topics. We're going to be talking about how to make LLM work in data teams. So not so much cost, and although we will talk a little bit about cost, but we're going to talk about the human, societal, and basically friction factors that make or break data and AI teams. Ooh, I am moving a little too fast. There you go. So just a little bit about me. I'm Jonathan Rioux. I'm joining from Canada. It's the middle of the night this morning. Today it's approximately -10, so very, very cold. I'm a data scientist. I come from an analytical background. I mean, as a matter of fact, very analytical. I used to do a lot of risk rating, a lot of domain-specific modeling. I spent most of my early years working with subpar stacks and trying to build models that had impact for millions and billions of dollars. If you think about, life insurance policy, fraud, risk rating, qualifying people for mortgages, those kind of things. So when I moved into more of an engineering discipline and I joined EPAM, I got very interested about the differences that you see from what we would consider like old school analytical team and new school analytical plus tech team, and then started seeing those kind of flavors as we're going to talk today. What does it mean for large language models? I talk a lot with my hands. You can probably see everything. So I have a coffee on the right. I hope I'm not going to spill it, but this has happened at previous conferences. It's also, if I ramble a little bit, it's also probably because I'm not caffeinated enough. So what we're going to be talking today, we're going to be talking about the definition of LLMOps. How do you make LLM work for a company? We're going to look at this from 3 major point of view: people, process, and platform. I'm going to explain what do they mean, what are the big changes, if any, when we are looking into effectively managing LLM models in production. We're going to be talking about connecting those 3 pillars. And then finally, we're going to talk a little bit about what has happened in the past that can teach us about the future. So the talk is about the present, where we are, but where do we think we're headed? And I think there's a lot we can learn from what has happened in the past. So how this talk came to fruition. So for those who've known me, I was with EPAM for a couple of years. I left. I tried actually to create my own dream data team in a startup, and I kind of failed. You know, a lot of things worked. Ultimately, the reason why I thought it would fail ended up not being the reasons at all, and it ended up being a lot more subtle and a lot more painful to admit. But I'm a compulsive doodler, so I every single time I read something, every single time I have a conversation with someone, every single time somebody says something to me that has an impact into how I think, I make one of those cards. And the collection of all of those cards is a little bit how I've articulated my positioning, and I hope it's going to influence yours today. If you are in a situation where you're developing LLMs, if you're in a situation where you're managing a data or an AI team, or you're in a situation where you're trying to steer this program, I think there's going to be something useful for you today. All right, so first of all, if everybody is with me still, we're going to talk about what do we mean about LLMOps. I think there's 80% of the conversation that I've had was, what does it mean? And I think a lot of people are pushing in the same direction. They're just starting with a different definition. I'm going to present mine. I hope it aligns with yours. I'm very interested if you're like, Jonathan, this is not how I see it. This is how I think LLMOps work. I would encourage you to reach out if you have any. The question period, I think, would be wonderful for this. So in order to start with LLMOps, I figured we were going to start with, you know, the grand ancestor of all of those ops movement. And I'm talking about DevOps. So I put a definition here. This is a canonical definition that was provided by the founder of the DevOps movement, the people that have socialized the concept right from the start. It is a software engineering methodology. So I think it's important to say it's not a project management structure. It's not, you know, series of process checkboxes. It is something that is core to the engineering. It aims to integrate the work of the development and the ops team by facilitating the collaboration and shared responsibility. In practice, we see this by fusing the team, one team that do it all. You know, we focus heavily on the tools, on simplifying the tech stack so that, you know, you're limiting the friction, which is what we're going to spend approximately 10, 15 minutes talking about friction, in a way that ultimately makes the software development process more efficient. So if we're looking at LLMOps, I think it's natural to be able to keep the ops portion, but add LLM. And I think, you know, for a lot of people, it's going to be a little bit scary because, you know, we're bundling more and more things into the definition. But to me, LLMOps is the same thing that happened to DevOps for development team for LLM product. So same thing, software engineering methodology that aims to integrate the development of LLM products into and operations altogether. One of the things that I want to acknowledge is that, you know, not to say that a software product is easier to develop than an AI product. I think, you know, it's important to be very clear that they come in all shapes, flavors. There's very simple forecasting product that do not require a lot of ecosystem. The stack is very mature. It's very easy to be able to iterate and go. But what I'm talking today is kind of the conceptual complexity. How do we accommodate, you know, the development of those products as a whole? So a thing that I want to re-emphasize, and we're going to talk about this throughout the talk, is an LLM application is first and foremost a software product. There is, whether you're doing it or somebody did it for you or you use a no-code platform, there is a development component that needs to be managed. There's also a data component that you need to manage, regardless of if you're using a third-party LLM and that's it, or that you're building your own model. If you're not using data, you're producing data, and there is, you know, a life cycle and a process and some operations consideration to be able to have. An LLM application is an ML product, so there is, you know, a discipline called MLOps that has been tackling a lot of the issues that are coming there. We're going to touch upon them a little bit, but this is not necessarily a talk about MLOps specifically. And then finally, an LLM application is an LLM product, obviously. So you're adding layers upon layers, and some of the time we have a tendency to see this like a sandwich or a lasagna, where, you know, you have those kind of like big coding. In practice, they get intermesh. You do one thing and you switch to another. And a consideration for somebody who's very MLOps forward might not echo the consideration of somebody who's been doing traditional DevOps. This creates inconsistency. This creates debate. And ultimately, I think it waters down our ability to have an efficient LLMOps framework, which at all time, every single time that you add confusion, friction, problems, you're just limiting your ability to deliver stuff. So the first question that I'm going to ask is, okay, sure, LLMOps, you know, data, ML, dev, whatever. If we're looking into that consideration where we're really, really focusing on limiting the friction through the value chain, meaning a team is responsible for the whole development, operationalization, and maintenance of the product that they are doing, I think it's fair to ask ourselves, can a single team do it all? And I'm not going to answer this question today. I think everyone, as part of their team, needs to look at their product portfolio and take a hard assessment of what are you doing right now? Where do you want to go? And can a single team do it all? Are you structured in a way where a single team do it all? Are you shipping products in flight from one team to another in order to be able to get something to the finish line? I want to acknowledge, like, I'm looking at this. This is something that I have collected from all of the conversation that I had with my peers at EPAM, from data governance, data ops, our data scientists, our ML engineers, our governance, ML governance people, responsible AI, security, all the way up to legal. There's a lot to be done there. How can a team do it all? And should a team do it all? Which is why I want to nuance LLMOps, which is the DevOps extension to an LLM workflow, and LLMOps really separating and talking as a whole about how do you operationalize your LLM application. And it means that you can take a very opinionated framework, a very engineering-centric framework, such as LLMOps no space, saying one team should do it all, one team, you know, needs to be responsible, we need to limit the friction as much as possible, and talk about this as a whole. Because I think ultimately the conversation becomes very unproductive if we're being dogmatic about where you are, where you should be, and we're not allowing for nuances for folks in their journey. Especially for a technology that is buzzworthy as LLM, I see a lot of people stalling themselves and saying, if it's not perfect, we're not doing it. And ultimately, the world is growing with imperfect but very useful products, and you're losing precious time in your ability to develop and delight your customers ultimately. So this is something I stole. I'm going to give credit to where credit is due. This is coming from a conversation about, I would say, probably my favorite person to have debates with at EPAM. His name is Dmitry Suslov. He's a lead solution architect, a lead data solution architect, and I've been probably learning more about the engineering perspective of managing models and especially ML and LLM models from arguing with him. We agree on some key points. Sometimes we disagree on semantics, and all of the debates that we've been having have been remarkably useful. The ops movement to me is, and I mean, I'm not going to put that on a slide that blunt, but like, it's about people that need to build shit using technology or stuff. So, we're really looking at how do we get people to build something as efficiently as possible, as reliably as possible, and of course, it is a technology movement. So there's always a technological component to be there. And if you look at how the talk is structured today, we're talking about people, process, and platform. I chose those three words because they all start with P's. I like a good, good tidy acronym. It makes it easy to remember. I'll trade a little bit of precision for beauty there. So all right, so we're going to talk a little bit about people. What's happening with LLM is a magnification of an issue that I've been seeing over the past couple of years, and I'm going to call this the shift left. Bear with me. I'm going to explain this in just 15 to 20 seconds. In order to characterize the problem, I'm going to talk about the value loop of a traditional ML product, and to me, this applies also to LLM, and as a matter of fact, this probably applies as well to software. We're just going to replace model development, like all of the model with product. So there's requirement, and I'm putting this very, very broad, but like there's requirements. What do we want the product to do? What do we want the model to do? And so on and so forth. You develop. You do a little bit of like what a lot of people are calling MLOps. So registration, selection, evaluation, management, versioning, so on and so forth. Where does this need to sit? How do you observe this? How do you keep track of them? All of those consideration gets there. Anybody who's using a product like MLflow, Weights and Biases, Equasio, you're probably already familiar with that kind of workflow. You deploy the model, and the model is touching either your blue-green environment, or you're having a champion and challenger. You're progressively loading the model, or you deploy in prod and you pray for the best. A lot of companies are still doing this, and then you observe. You monitor, you look at your metrics, you basically see how it behaves, and this will ultimately influence your requirements, and you continue that cycle again and again. Not everyone is repeating that cycle. We see a lot of like version 1 being the final version, and then model being orphaned because company is not putting a lot of focus. We're not going to talk about this today. We're going to assume that this is the process that you're following, and you're pretty disciplined about this. So, all right, I've just unpacked this into kind of a line, but I want to make sure that folks understand that this is kind of a cycle. It's just to make it easier. So, a traditional ML product development, and we're going to talk about this by competence. You have your business users that are going to come up with your requirements in kind of an old school fashion. Like, this is happening in a boardroom and this is happening virtually. You're going to argue about like what the product needs and needs not to be done. There's usually going to be a little bit of technological people that are going to say, this is feasible, this is not feasible, we can do this, we can't do this, so on and so forth. But this becomes traditionally a business problem. Your data scientists are going to be working on a model development all the way up to an artifact that's going to be into your registration model, your registration product, sorry. Developers are going to develop the ecosystem around the model, your app. And then there's usually another team, like some people call it ops. For here, I don't want to confuse the language. Like we're going to talk maintenance, ongoing, I'm not shortchanging the importance of that team. I personally think that they are the unsung heroes of most organization, because this is what keeps your light on. This is what keeps your money coming. So I know a lot of people are looking into building something new, but hopefully the cycle of how much value a product's going to bring is going to be a multiple of the time that you've spent developing it. If we're looking at this into a traditional MLOps product development, what in theory you should have business fuse with your product team. Unfortunately, what I have seen in a lot of companies is used to have a separation between your business, your product user. The traditional, I'm not the technical person, but I lead technical people. We see still a little bit of friction. This shouldn't happen, but we see this happening. I mean, as a matter of fact, like I can think maybe of 2 or 3 companies that I've seen I've been in the market for almost 15 years, where business users were at the table from one end to the other and taking co-ownership of why the technology, the product is. And you're going to see this very vividly when the product will break into production. You're going to see a lot of business people trying to skirt themselves away from the responsibility, saying my requirements were clear, the technology is just not working. To me, this is a clear sign that ultimately the ownership stops somewhere, and usually it stops at the requirements. The business user has no skills and no appetite to acquire those skills to be able to continue into the process. If you're a product manager, you're a product owner, you're listening to me today and you're like, Jonathan, you're full of shit. I stay with my team all the way through the process. I say good for you, because this is not something that happens very often. And I mean, I've been a business user. I've been that guy who the technology doesn't know what they're doing, and basically trying to issue myself on the responsibility. So I'm guilty as everyone, not because I'm not technical, but because sometimes the role warrants it and you don't have the visibility that you want. LLM, there's something a little bit funny that's kind of happening there, and ironic that I was scratching my head, but the prompt engineering makes it easier for the business user to experiment. I like to talk about large language models as not only a revolution in technology, but there's also a UI revolution, and not in the way that we would talk in terms of brand new product, low code, no code, but the English language is kind of the ultimate low code platform. A lot of people now can prompt engineer the model, get immediate feedback. And anybody who's worked in a data science project where, let's say you're doing a forecasting or a classification model, and your stakeholders are cherry picking a couple of examples, and they are saying, well, your model's working or your model's not working because I've tried it on 3 examples. They're great, they're not great. And this is going to have a bigger weight than any of the metrics that you can provide, because it looks real. Now, take a step back, put yourself into the realm of a business user. Now, out of a sudden, you have a hinge. You can prompt engineer your way into getting the results that you want. So what we're seeing a lot of business users that, to no fault of their own, I don't want to say, business user bad, technology good, but you're able to get a glimpse into some of the first steps that, the ideation, the back and forth of your ML product. You're able to prompt engineer your way into something serviceable. And this is pretty powerful. It can help a lot your discussion. It can help a lot, share the responsibility. But one of the things that is not mentioned enough, and I think is important to reiterate, is this is one thing out of the whole flow that becomes visible and therefore has a lot of importance. But there's a lot of things that are still out of reach. You can't ask a business user to be able to provide you with a complete RAG. You can't ask a user to manage efficiently model decay. You can't ask a business user to manage hallucination or monitor the model in a painstaking manual fashion. So those elements are still important. As a matter of fact, they're even more important. We're going to talk about this in the platform setting about the challenges of using LLM. But as a business user, you have a new tool, and it's great. But it is important to put this into the context of the whole value cycle and not stop at, well, I've engineered my prompt, like, how hard could the rest be? Turns out pretty hard. And we haven't had necessarily a chance to crisp up and crystallize how we can do this in an efficient fashion. We'll talk about this when we discuss about process and platform. So the key learnings that I've seen from an LLMOps framework, and this came through a year of managing first-party and third-party LLM tools, LLM teams. The process and toolings for those activities is not yet supporting this shift left. The user experience for prompt engineering, the ability to do things right in a way that is contextualized to the product, the tooling is not supporting our business user properly. The LLMOps stack, which we're going to talk into a couple of minutes, is also not supporting this shift left-right. We can't put the burden on people to compensate. You can't throw more people to the product, to the project, to compensate for unclear or uncrystallized processes. It just makes things slower. Everybody comes with their own perspective. It creates useless debate. You're not fostering. The more you debate, the less you're experimenting, the less you're learning. Sometimes it's even better to do something subpar just so that you can learn faster. As a leader, it's important to build realistic people goal to adopt, understand, and effectively manage generative AI. And we're talking a lot about how we're structuring ourselves. How do you want your team to be enabled? But in terms of skills, in terms of competency, what are you, and I'm talking globally, what are you doing to educate your business users? How do they understand how the technology works and how can it yield value? I find it extremely hard to imagine someone capable of harnessing the power of generative AI without understanding the efficiencies and trade-offs of the technology. So as an individual, what are you doing to educate yourself on the realm of generative AI or AI as a whole? As a team, what cross-functional skills do all of your team member, all of your company needs to acquire? And then how do you use that to support the development of the products? Process. So we're going to move on away from the people as individual, and we're going to talk about how we're organized them. I have a tagline at the bottom, and this echoes. This is probably my favorite part of the whole presentation because I've seen this crash and burn so many times. It's almost like a soap or a sitcom for me. I shouldn't like this the way that I like it. So we're going to talk about the two types of team management and what's wrong with them, and why, unfortunately, I don't think we can do better. So this is your traditional by competence team. So you have pools of people. So you have a business team. You can call it product team, business analysis. There's plenty of words that can perform that function. You have your data scientists that are organized by competence. So you have a pool or a team of data scientists. I'm not talking about a consultancy model. Like, this is very different. I'm talking about you're working on something for a customer, or you're part of a product team at a client. It's very different from a consultancy. You can't organize yourself in a very different way. Sorry, I got myself a little bit sidetracked there. And then you have your application, and you can see that you have boundaries that are put there. So basically, your data scientists are hanging with other data scientists. Your software developer are hanging with other software developers. You create functions. Your DS leads can kind of go into requirements and talk a little bit about the models. You create professions like ML engineers to be able to straddle a little bit between your model and your application. And this is all fine, fair, and dandy. So before we start talking about the pros and cons of a model like this, I also want to illustrate the second one. And this is your traditional quote unquote MLOps, LLMOps kind of framework. You're organized by delivery, or you're organized by product. You have a product owner, your business stakeholders that is like through thick and thin into the process, owning and being responsible for all of the metrics related to that product. And then you have a team that works on that product. This is how you see, from my experience, high-tech company have a tendency to be able to create those specialization. The know-how between product line is usually very different. So naturally, you will have a tendency to converge into this. If you take, kind of a research organization, your projects are going to last for like multiple years. You might be working on something that is heavily complex. Let's take a self-driving car, for instance. You're working on the collision detection product. You're not. You're not going to be part of a pool. Like you're going to have your data scientists within your team. There might be data scientists that are going to be working on the LiDAR or something else like this. But the organization is really about the product. And this is quite different. You see the organization, and usually you're able to pick up exactly how they're orchestrated and how the things work for the company. So a little bit about, kind of a quick description. I want to talk, because this is going to be very important, is the horizontal friction, by role that you have. And I say horizontal friction because, drawing a horizontal line, you're crossing a lot of boundaries. So this is where your friction is happening. You're allocating your talent based on work. Who do we have available will dictate what kind of work you can do. And this ultimately promotes resiliency over efficiency. We're going to talk about the difference between those things, but as a whole is you're able to reallocate people a lot more easily if the business priorities are changing. But on the flip side, your folks are less deep into the knowledge of the company and the product that they were in a deliverable-based organization. Vertical friction. So basically, the friction is happening as you're trying to drill down into competency. Let's say you want to bring all of the data scientists and do something with them. This is going to be a little bit harder. The efficacy equation, you're really, really focusing on over efficiency. You have focus on a product, you're usually quite sheltered. But on the flip side, if priorities are changing, usually the whole team goes bust. It's really hard, to be able to say, well, we have something new, and to be able to blend the team. So I don't want to be dogmatic. I know a lot of people say that, the product-led delivery is the way to go. I want to acknowledge that there's pros and cons for both of them. One of the key things that is easy when everybody who knows the same thing stick together, there's functional knowledge dissemination that is accelerated. Your center of excellence boundaries become a lot easier. It's easier to be able to set the tone about how things should be done, and therefore develop best practices. On the hard side, coordinate the development and the delivery across team is difficult because you're going to have multiple people working on multiple issues. So sometime what it's going to create is it's going to create a bottleneck or a standstill where, you have out of a sudden, like you have a team of software developers or ops people that are going to need to deploy half of the models that you have into production in a 1 week period because there's a break fix that needs to be addressed. Not going to happen. It's also hard to be able to instill a sense of responsibility. You're going to see a lot in those kind of function. You're going to see a lot of what we call human API, which basically each function into the pipeline is going to create insanely hard requirements to be able to get the previous team to talk to them. And in practice, we see that where the data scientists hate the ops team because the code is never good enough. You haven't set yourself on the new canonical libraries that we're supporting, and you're a couple of versions behind. So fix your shit and come back to us. And then out of a sudden, it becomes kind of an implicit stakeholders, and you just have a tendency to get the garbage floating up into the value chain. The data scientists are going to turn themselves and say, well, your requirements, business person, are not clear enough. And you create those rigidity and that kind of hostility if you're not managing this effectively. Conversely, on a product base, rapid product delivery and iteration, it's nice when everybody works on the same thing. It's really, really cool. It facilitates, you want to be able to keep people busy. You want people to focus. So you have a tendency to iterate a lot faster. There's a lot more business focus. People are hungrier. The issue that happens there is it duplicates a lot of function. So a good example, in a perfect world, if you have 8 product, well, you need 8 product team. Do you need do you need a developer on all of those 3 products? I feel like you could split him between those products, and out of a sudden you're crossing the boundaries and you're creating what's called a multiple masters problem. Let's say you're a software developer and you're working on product 1, 2, and 3. All of them are in crunch mode. You're officially the bottleneck. You're breaking the whole process because you're removing focus from a team that is all about focus. So this kills that kind of framework. Also, how do you deliver best practices? Do you need to have, another vertical center of excellence kind of point? And this becomes something that to me strikes always a little bit kind of weird. You see product-led team with a center of excellence that is coming up with best practices, but the people on the ground all agree that the center of excellence is developing things that are not useful, that are not easy, and that are not relevant for the job. So you end up having a completely disconnected process map that does not reflect how the work is being done on the ground. So this creates additional friction. So the thing that is interesting about this is that for a process that is meant to be able to reduce friction, in order to be able to foster harmony and community, you need to instill friction at the right spot, and it is incompatible with your incentive at first. So there's always going to be a little bit of awkwardness, and managing this can make or break your team. It's not about the if, there always will be. It's about the how. Okay, Jonathan, you've been rambling for a bunch of time, and I looks to me that I'm going to go over, so I'm going to accelerate. What does it mean for LLM? LLM is new tech. So a new and immature tech leads to a talent shortage. And we can use this as an example. How many LLM professionals can we have if the technology was virtually unknown 18 months ago? This leads to a talent pooling. You will have a tendency to create a center of excellence. Everything needs to go to those people. What happened? There's rigid barriers, there's gatekeeping. This is just natural. You want to make your job easier. But what ultimately this gives is it gives slow delivery and time to value. That leads to, we need to change how this is being done. So you do product-led delivery that leads to a tech stack simplification, because not everybody can keep everything into their head. So you might forego, your full-blown Kubernetes delivery stack and go with, something a little bit simpler to be able to deliver your ML product. And you might take a couple of shortcuts into some of the tools that, it's not going to be perfect, but it's going to be simpler. This also leads to decentralization, a faster delivery and product innovation, which ultimately leads to new products. And this goes back. So we have a tendency to go back between. And if you talk to a couple of very high-level leaders, we're talking vice presidents, chief AI officers, they're almost like the rooster on top of the barn. And they're like, oh, yeah, new tech, we're creating a center of excellence, where those same people were like, we need to be efficient and focused. And this just depends on how mature the technology is. On the first side, it's motivated by a talent shortage. And once that talent shortage is addressed, you will have a tendency to transition into a product-led organization. Key learnings for that section. Friction trades efficiency for predictability. And this is important for leadership. They want to be predictable. As leaders, we use friction to stay on top of things. We put processes, we force our team to slow down so we can stay on top of what's happening. Therefore, you can't eliminate friction. You need to put it where it belongs, and you need to act accordingly. Putting friction, if it's not being used for knowledge dissemination, is completely and utterly worthless. As you go, I want you all to go into your respective team and think about the efficiency versus resiliency trade-off. How do you maximize this? Are you in a team where the priorities are constantly changing? Or are you within a team where the product's been running for a number of years and you really need to be able to get things efficient? This will determine how are you going to structure your team and where you will implement friction as part of your process. We're going to talk finally a little bit about platform. This is a very, very high level, kind of an executive. This is how I talk to my boss about how overall, an LLM app work. So you can see there's a lot of components that are pretty familiar. We're going to talk a little bit about the differences right away, as a matter of fact. A couple of new things that are happening. Vectors and embeddings, they were something that were real in the world of NLP. I don't think this was taught nearly as often. I think now any AI leaders knows or must know what a vector or an embedding is, because they're core to how an LLM operates. There is also a proliferation of cache. I think that the cost of doing those kind of LLM and the predictability, and also people are realizing that the questions are often quite similar. So whether it is a human cache, so you're creating pre-baked answers in a way that's being accelerated, and then you're serving them using a classification model, or you're just caching based on like the similarity over a previous question that was done. This is something that always, it existed, but I think it's a lot more prevalent. So I'm considering new things. And model instructions are also quite new. It was rare in the AI kind of space that you would have, as part of your model, like, extensive instructions that would be pre-baked in, and kind of a two-stage process with like instruction and prompt. Usually that was part of your training process, and you would push the logic into the application. This is something that I would consider a little bit new. On the things that are being different, and those ones I'm actually more interested about, because, pardon me, it breaks a little bit some of the efficient process that some teams have been done. unstructured input and responses, which means that your telemetry, your model registry, your observability now has unstructured data, which comes with its own set of challenges, and it is something that needs to be addressed. Are you going to get PII into your response? Are you how do you measure efficacy of your model? How do you measure accuracy? How do you monitor for model decay, and when do you need to fine tune or retrain? How do you fine tune or retrain? What is the reason? It's no longer like, oh yeah, we're just going to do a refresh every 3 months and see what's going to happen. There's a lot more nuance that needs to be done there. There's also a proliferation of third-party foundational model. In the case of NLP, I know there were some, BART or BERT as a service in the past for companies that didn't want to bother, but this is not, or at least this is not something that I was personally very exposed. But with OpenAI, Cohere, Anthropic, and so on, not only third-party models are prevalent, they're also kind of the norm now. Like out of a sudden, in one single generation, we went from train your own model as you if you want to train your own foundational model, this is out of reach for a lot of people, and kind of reminds me a little bit what happened when we were at the beginning of deep learning. Like a lot of people were not they were just doing stripping the last few layers and just training on top, and we're still seeing that a lot, but the technology has pardon me, evolved so that it's cheaper now to do that, and I think the same thing is going to happen. But 8 H100 GPU is out of reach for a lot of companies, both from a money or just an availability perspective. And then finally, the orchestration as a component. So this led to me to something that I call the Octopus app. I really wanted the Octopus to be able to have 8 things, but I decided that I'm not going to fake it. But you end up having an orchestration layer, and LangChain, Llama Index, Semantic Kernel, all of those projects. They're not mandatory, but they make your app a lot simpler, but they connect to a lot of external services. We used to see the ML app, the model, as kind of its own monolith, and then you could have the app, but this was something that was usually kept a little bit separate. Now your LLM, especially with third-party model, your LLM doesn't really work if it doesn't have those components. You don't really have anything useful or anything differentiated. Your value is in that orchestration that you're doing. So this is something that's quite interesting, and it adds a lot of complexity because all of those services require often different set of skills, and you're not always going to need them. They come, they go, depending on your use case, which adds to kind of the uncertainty on how do you manage this thing overall. Furthermore, where from a technology standpoint, there's still a big questions about where you're going to put your ML hinges. In the traditional ML, your weight were with your model. Your model comes with its own weight. I feel a little bit stupid about even seeing this, but the application logic was within the app. But we have something like context, like prompts. Where do they belong? Do you want them with your model? Do you want them as part of the model weight? And how often are you going to change them? How often are you going to adapt? Is your system prompt different than the user prompt? How are you going to do your scenarios? The stack hasn't followed really well, and a lot of products are taking a different perspective. We're seeing kind of that opportunity space, and every product is trying to make that their own to be able to increase the stickiness, which we're going to talk a little bit about, 2 tools to do everything. But you need to ask yourself your question as you're developing a product: where do you put the damn thing? I'll use an example about technology decision and how they can impact ultimately how you do things. Vector store. So this is something I think I've spent a lot of time talking about vector store, which I find kind of fascinating because the technology is extremely boring in its application. But a lot of people saw, especially in the context of RAG, which is retrieval augmented generation, basically combining search with your LLM to be able to give them the information to answer a question. There's some people that says that this is something revolutionary and warrants a brand new tech approach. You have to invest into a bona fide vector store technology. There's some people that are like, PG vector is going to be good enough. I have a Postgres database. I can use the extension to be done there. My use case do not warrant to invest into new technology. And then I'm going to give a shout out to our hyper competent people that are into the search space. If you get to think about it, this is a search problem. Why do we need a new technology? And this is a fair question. Where do you fall into the spectrum? I would venture that a lot of decisions that are being made because of the newness of the field is not motivated by an actual technological need. It's only motivated by your ability to follow trends. And this is pretty dangerous. Everything that we've learned so far about good software procurement is going out the window because you do not want to leave this out. So your tech choice can accelerate or halt your delivery. And I think it's important that your overlap in functionality needs to be explicitly addressed. You need to efficiently leverage your tech stack. If you don't know how to use your tool, and if you're a leader, go spend time with your team and look how they use your tech stack. Learn how they use your tech stack, because you'd be surprised that some of the time they're complaining about functionality that is already there. When I ran my own data science team, I can use this as an example. MLflow wasn't used properly. And I was like, why am I not getting the numbers that I want? Why am I not able to monitor this? And it wasn't a technology problem. People were like, well, no, MLflow doesn't do that. No, the previous version of MLflow didn't do that, but we're 5 or 6 versions forward. It does it now. Are you staying up to date with your technology? Differentiate where it matters and simplify where you can. Not everything needs to be top of the line all the time. And be mindful that everything that you add as a technological differentiator will mean that you need to train your team. If you introduce tech and you don't have a change management process, you're part of the problem. So connecting the 3 pillars. So LLMOps is about skilled individuals doing the right thing at the right time with technology that supports them. Where does it get wrong? Where does it go wrong? If you just focus on your talent, and this is where a lot of LLM teams are being done, we're like talent. The team consistently get blocked. The process does not support them. You're always waiting for the next thing. Data quality issues creeps in because there's not enough focus that is being done there. It's hard to get a product to production. There's a low to negative ROI on your investment. Personnel is demoralized because nothing works. And then you're seeing leaders that are saying AI doesn't work for us. Like, this is usually what we see.
Jonathan? I'm
Yes,
afraid we are running out of time.
Yeah,
This is really amusing and interesting, but we should be like...
Can you give me 1 more minute? I have 2 more slides.
Sure, no problem.
Awesome. If your process are too stiff, your innovation falter. And then the final part is, if your technology forward, nobody knows the system. So everybody starts to improvise. You're seeing, and this is kind of the big factor, your data platform team becomes bigger than the client that they're looking to support. And then you're talking about ROI. So for LLMOps, I mean, this is kind of the key learning. Your people needs to acquire and have the skills, the latitude, and the incentive to perform the task on the platform. Your process needs to be grounded, understood, and challenged, and they need to exist for a good reason. If you can't explain the why you're doing something, stop doing it. And your platform needs to make the process simple for the individuals. I'm just going to talk a little bit about kind of the hype cycle that we see, and not necessarily because LLM is at the height of the hype cycle, but this was 2019, 2021, and 2023. I've been through a lot of hype cycles there, and what I've seen is we have a tendency to overcompensate by putting more people at the problem to overcome the fact that we're not mature on the process and the platform. And this does not work. As you're doing an LLM team, ask yourself those 4 questions. Where are you putting your friction? How do you allocate your talent? What are your constraints in doing this? And more importantly, what do you value? And this stems to finally, which is going to be the question that I want everybody to leave as you're looking into navigating this. How do you operate? And that's it.
Thank you, Jonathan. It was very inspirational, interesting, and a lot of new information I found for myself. Thank you very much. Okay, guys, I don't see the questions in our chat, so I assume that Jonathan covered pretty much everything. And no one even have anything. And
yeah, I will take all the hate mail,
yes.
Separately.
Thank you, Jonathan, again. And we are still halfway of our event, and I hope you like it. And if you do, please don't forget about our social media activities, and you will really, really help us if you help to promote us on this event on your social medias. With the hashtag Autumn Conference. You can find it in the description to the event, and do that. And I remind you that we will pick up the winners, and you will get the gifts for these activities. So now I think it's a good time to knead our limbs, to boil some tea, and return to another topic in 5 minutes. So please stay with us. Thank you. Good. Hi again. We are back on the air, and I am reminding you about our contest, about our quiz, and that you can switch the stream if you think that some topics can be more interesting, but I still encourage you to stay with us. We have many other speakers ahead, and you will love it. So, let me introduce our next speakers. We will talk about life sciences, and we have our best experts. We have Ted, we have Andrea, and we have Philip. And they will tell us about the specifics of architecture and about the data-centric approach related to the life sciences, and we will get some interesting and useful insights. So, guys, word to you. Thank you very much.
Thank you, Daria. Hello, everyone. Okay, so I'm going to help open this up. My name is Andrea. We're going to talk about, with me first, what are the changes that are happening in the life sciences industry, and then I'll turn it over to my colleagues who will then talk about some of the data management practices that will support these changes. So again, I'm Andrea. We have joining me Ted Slater and Philip. Why don't we go to the next slide? We will introduce ourselves, and then I'll get started. So, as I said, I'm Andrea Sorkin. I am a member of EPAM's Life Sciences Data Practice. I've been in the life sciences industry for over 20 years. I actually started out once upon a time carrying the bag. I was a drug rep. Before that, I actually was a patient advocate. So I have been sort of merging both these worlds for some time. My passion is really around, within life sciences, the changes that are putting patients in the driver's seat and improving the experience, particularly of patients with rare diseases. And it's a very exciting time to be in the industry because of the opportunities that we now have to treat patients who previously didn't have these options. So that's my background. We'll talk a bit more in a minute. Ted, why don't I turn it over to you to introduce yourself?
Thanks, Andrea, and hi, everyone. My name is Ted Slater. I'm in scientific informatics here at EPAM, where I've been for about 1.5 years, I guess. My background is in molecular biology and computer science, and data has always been my thing in this space, and I'm one of the co-authors of the original FAIR data paper, so I'm excited to talk to you about data centricity in FAIR today, and I'll turn it over to Philip.
Hi, everyone. My name is Philip. Solution architect and data practice. I'm working in my company for more than 20 years, and I covered a lot of different areas. And for sure, life sciences and healthcare are one of the most exciting areas because a lot of unstructured information we are excited to process in different ways. So I'm a semantic web and cloud computing and AI expert and evangelist, and I'm focusing mostly on building hybrid knowledge and recommendation systems. So welcome to our speech.
Thank you. Go to the next slide. All right, so as discussed, I'm going to kick it off. We've done the introductions. We'll talk a bit about some of the changes within the life sciences industry and how those changes are making it more and more necessary to break down some data silos. We'll then turn it over to Ted. As he mentioned, he's one of the authors of the FAIR data, so he'll talk to you about what that means, and then Philip to tell you about how you then enable the architecture to support verification of data in your organizations. Let's go to the next slide, please. So just a little bit about EPAM and our life sciences practice. So you can see that it's the fastest growing area of our business overall. I think we're now around about 12% of the business, but what's really exciting in our data practice is it now makes up about 1/3 of our business. And you can see on the right-hand side, we have experts that support us all the way from drug discovery through to commercialization, market access. So pretty much all of the different areas of the industry we're covering. And we're actually partnering with about 12 of the top 15 life sciences companies around the world to do this. In addition to our data capabilities, we certainly have business consulting, user experience designers, change management, and of course, compliance and regulatory sits at the core of all of these things. So making sure that we're using data safely. As my colleagues here know, I'm one of the co-leads of with Ted as well, our Gen AI Healthcare Life Sciences think tank within EPAM, and it's been paramount to us to think about how do we use the new technologies in a way that's safe, compliant, protects patients, and protects you from only sharing data that is approved in your organization. So let's go to the next slide, please. So I talked about some of the changes that are happening within the industry. So from beginning to end, I think the biggest change is that we're now moving towards personalized medicine. So I had talked about the rare disease patient. And so now we're finally, through these personalized approaches, being able to give them opportunities to receive therapeutics that are really much more efficacious than anything they had before. But what does that mean to our business? Certainly, when it comes to R&D, we're now moving away from some of the small molecules and looking at some of the large molecules, trying to do genomic sequencing. This is where, when we talk about AI, this has been one of the biggest opportunities we're hearing where people want to invest. But of course, to be able to even do this and accelerate target identification, looking at genomics, and you need to have the right infrastructure and data management in place. Certainly, we next talk about data interoperability. That'll be a big theme today. But as you can tell, even with the COVID-19 vaccines, people are much more tuned in on how science is made, what it goes into this. And so to be able to provide that visibility, we actually need to have that data interoperability, not just within our own life sciences domain, but also with the healthcare industry, so that we can better report and have that traceability to our consumers. We talk about clinical trials. This is an extremely exciting time for that. The days of sort of site-centric trials where patients had to travel for hours, sometimes live in other places to get treatment. We're now finding with new technologies, there are ways to make clinical studies easier for patients to participate in, but you need to have the data infrastructure to enable that data to come in from all of those sort of decentralized devices and tools. Finally, this has been near and dear to my heart. When we think about the commercial ecosystem, we've moved away from sort of delivering a message from a rep to a doctor and really brought into more of the omni-channel engagement. But again, to do that, you've got to have all of the data, all of those profiles, identity resolution happening in your commercial data platforms so that you can really understand dynamically each customers' needs, preferences, and anticipate where they are in their journey and what kind of information they need and deliver it to them in their preferred channel. And then finally, of course, we talk about access and adherence. That has not gone away, but with the new specialized therapeutics, getting access has become even more difficult. So while we've made tremendous progress in developing new novel science, getting that made available to patients is a challenge. And then because there are sometimes extra hoops for patients to go through to stay on therapy, keeping them on therapy has become even more important, I would say. So we can go to the next slide. And so when we think about how are all these changes, what are they doing to the ecosystem overall, we see that life sciences companies are now no longer on their own. They're considered core to the entire healthcare delivery system. So seeing life sciences companies playing a role as a healthcare provider because of personalized medicine is really at the center of why we need to think about the ways that we use our data. So you can see on the left-hand side of the screen, there are some emergent medical trends. Patient consumerism, we talked about that. Patients really want to be empowered to make their own decisions. They want to get information delivered to them in a way that they can understand. And we talk about health equity. If you look on the right, here are some of the technology enablers we're seeing in the life sciences industry that are supporting some of these medical changes. And so you think about marketing automation and a way to really engage consumers. We think about decentralized clinical trials as a potential opportunity to close the equity gap in studies. We think about things like IOMT, telehealth, and we're seeing that life sciences companies are making more and more investments in digital health partnerships so that they can really track patient care. That also solves this problem of equity, making care available closer to home. we think about predictive analytics, understanding the risk, different patient populations, what the social determinants of health might be. That supports value-based care in the healthcare domain. And then finally, I talked about precision medicine, which relies on genomic sequencing. So you can see that these two industries are becoming more and more tied together. We can go to the next slide. So I won't go through this entirely, but what's starting to happen is to enable all of these changes, these domains of R&D, clinical, medical, commercial, where they were all working sort of independently, we now need to have that data being shared across all of these domains so that they can then be shared out. And so that means when you think about things like real world data, being able to use that to identify targets and then using that again in clinical to identify what kinds of protocols might work, where might we find patients who are available to participate in studies, how might that inform our medical affairs and scientific engagement strategy, and moreover, being able to share the insights from medical affairs back to the lab when we see new opportunities for research. So rather than the old way of doing things where each sort, not even each domain, but each brand kind of worked independently, we really need to see that there are data assets that now need to become part of your reusable infrastructure so that you can really have end-to-end, what I call research to real-world insights. So we can go to the next slide. And so what we're going to talk about as I turn it over to my colleagues is what does EPAM do that makes this feasible for you? And so we have what we call our data factory. That's the way that we think about managing data throughout an organization and throughout an enterprise. So there are two elements of this data factory approach. The first is obviously on the technical, making that data fair. You're going to hear a lot from Ted about our thinking around doing that, making that data reusable, but also giving it business ownership, right? So we think about data not just as its own entity, but as part of a larger data product that can be owned by business, reused for other business domains, but simultaneously we need to have the people and process in place to manage this data across the enterprise. And you'll see on the right-hand side of the screen, we've listed out some of the areas where we at EPAM like to focus our attention in the industry and using the data factory approach to be able to do that. So we talk about our experience in R&D and really being able to help scientists find the information they need to share experiments that have been done before. Within clinical medical affairs, we talked about decentralized clinical trials, finding insights. We're very involved now in using NLP to derive insights from some unstructured medical engagements that are occurring. But in order to do that, you've got to have your data cleansed and ready and available. And same goes for commercial when it comes to omnichannel. So that's just the introduction that I wanted to give overall to the rest of this talk and why we're talking about data management in life sciences and why right now more than ever it's incredibly critical that we get it right. So I will turn it over to my colleague Ted.
Thank you, Andrea, very much. That was a beautiful segue to this particular part of the talk, and I'm excited about this because there's hardly anything more fun than taking a different kind of viewpoint towards things from the one that you usually do. And that's what I'm really trying to do here. My goal is to get people thinking a little bit more from the data side of things than we do from the technical kind of application specific side of things. So first I'll talk about kind of data as a byproduct, which is that more traditional approach that we use most of the time. And I said data as a byproduct because a lot of times today we mention things like data as a product, which makes a lot of sense. But unfortunately, our approach to working with data tends to look more like data as a byproduct as we focus a lot on applications. So here's a picture that comes from Zhamak Dehghani, which is who is responsible actually for a kind of exciting approach to things called data mesh. And if you look at the original data mesh article that she wrote, you'll find a whole bunch of information about this, but I have borrowed this picture from that article to kind of describe what it looks like today when we build applications. Typically, our approach when we begin a project is to focus on the containers for data rather than the data themselves. We're worried more about databases and applications than we are about the actual data and what people are going to do with them and how they're going to interoperate with other data. Because it's the case that any non-trivial scientific problem that we're trying to solve, especially in the life sciences, which is incredibly complicated, requires data from more than one source. You can't get the answer to important questions in life sciences typically without getting data from a whole bunch of different places. So it's important to take a different approach here. What we get when we approach these kinds of things from an application point of view or a container point of view is centralized, monolithic, domain agnostic platforms. And let me explain domain agnostic for a second. What domain agnostic means is we don't really care what kind of data are going into our databases. We're just making sure that we hold them and check our box that says the data are safe and secure and we're not going to lose any of it. An important goal for sure, but in order to advance the scientific aims of the people who need to use the data, we need to be very domain specific. We need to understand the domain deeply to make sure that we're modeling data correctly, interoperating data with other sources, and etc., so that we can use the data better. What we have to do to approach data in this application-centric way is have specialized data engineers that manage the pipelines and clean data up. It's an expensive proposition because you have to make sure you have a bunch of them. And we'll see in a second that those efforts have to be duplicated in the organization to make things go forward. What we do here is we extract information from whatever repository, and that repository tends to look like a data lake, for example. And every application that we need to deliver to the people who need to use it has to have data copied and cleaned up or transformed in some particular way, put into a new repository, which is just duplicated data in the organization, and then a new interface or set of interfaces have to be developed so that people can actually use the data. So lots and lots of duplication, lots and lots of effort. And pretty soon that application and that database will just become deprecated and go away. It happens all the time. So this is really expensive, as I mentioned before. Part of it's because we just have too much data to manage in that way. That whole process of duplicating data and moving it to a new repository and cleaning it all up is just incredibly difficult to work with. You have to parallelize it to one extent or another. It just means you have lots more people than you typically would need to have. And then you're duplicating data, which leaves yourself open to errors in duplication or some other kinds of errors that come from stale data. So data will change in one place and not be reflected in the same data in another repository. It can be a really difficult problem to deal with. It often results in vendor lock-in because organizations will pay other companies to build software or they'll buy software and move their data into it for temporary purposes, and then they're stuck. They can't move the data off of that platform. And we heard Jonathan earlier today talking about innovation being slowed down. This is another way innovation can get slowed down. Operating in this way is very slow and complicated, and you have no fluidity in your data to support the innovation that you would like to do. Researchers, especially in life sciences, have lots of ideas about what they could do with data. But sometimes on the IT side, we train the researchers to not even ask the questions that they want to ask because it's just too difficult to wrangle the data into shape. So that's a real problem. The other problem is that data themselves are just not incredibly useful when they get moved around in this way. The identifiers that people assign to entities in the new data are not typically GUPRI. So you'll hear this acronym a couple of times here. A GUPRI is a globally unique, persistent, resolvable identifier. Resolvable means that it looks like a URI in one way or another. Those are important properties of identifiers, along with other properties that look like opacity, for example. So you can't tell by looking at an identifier what kind of entity it's naming. So only locally useful identifiers means that you are going to be in trouble when you're trying to interoperate or integrate your data with other things where the identifiers are different. And now you're stuck with a mapping problem from one entity to another. The other problem here is that data are not even interpretable, at least not readily, even if you can find the data. So there's just no semantics associated with the data. The metadata are bad or completely missing. And so when you find, even if you can find the data, if you're lucky enough to find it, you don't know what it is. So you don't know what to do with it. There's data duplication, of course, and it's all too slow and too expensive. And the real problem here is, at the end of the day, when you look around your organization, you see a legion of data silos that you've created by taking this application-centric approach to things, copying data from some repository, putting it in a new repository, adding a bespoke application interface to that thing so that people can use it. And now you're just stuck with a million data silos, and everybody complains about them, but there doesn't seem to be too much progress sometimes in fixing that problem. This is really expensive, and 40% of a typical IT budget is spent just integrating data from disparate sources. It's a hilariously big number, and we need to be better at that in order to make our IT support lines work better. So that's a key factor here. Reusing data is not practical in this scenario, right? So using data here in this way almost always means this cycle of replication and cleansing, harmonization. Sometimes you have to do this over time. So you do it on an ongoing basis as new data comes in, and you have to go and transform it for each of the applications that uses it. It's really tough, and it's expensive and time consuming. So sometimes it doesn't even get done, or it never starts. So you end up with projects that languish because you just don't have the resources or the will even to make them go. And then things like advanced knowledge engineering solutions like knowledge graphs and similar things that could really be beneficial to the organization are super difficult to implement. So they don't get done either. So, and things like data mesh. So you saw that picture from data mesh before, the original article. That's just not an option because the data aren't in such a state that you can support that kind of activity, which is too bad. Because in life sciences, and here we're talking, or Zach Kohana actually is talking about medicine, and he says, and rightly so, that medicine is at its core a knowledge and information processing discipline. That's what it is. So we're really working with data. Zach is not mentioning databases or applications or anything like that. He's talking about data. And the great thing here is that Martin Romiker of Rioux, a good friend of mine and a really smart guy, said some years ago, applications come and go, but data persists. And that's a really important thing to keep in mind. And when we say applications here, we are also talking about other kinds of infrastructure, databases and pipelines and those kinds of things. Those things come and go based on the needs of the researchers in an organization, what they're trying to do with the data in a particular time. But the data will always be there, and they're often useful over time, especially if you make them reusable so that they're findable and interpretable for their lifetime. So now I want to talk about data centricity, and I want to talk about that because Martin Romiker is dead right about that. And data centricity is a different approach that we can take to data that helps us get over some of the things that we've just been talking about. So data centricity is just the concept and the practice of positioning data as a core fixed asset that doesn't change regardless of the technology that uses it. That's a really important point. So there are many definitions for data centricity. This is one that I particularly like because of that agnosticism towards the technology. Your data should be independent of the technology on which it resides. It has to live somewhere. Don't get me wrong. There has to be a place to put the data, but those data have to be independent of where they're existing at a particular time. Again, because applications and databases, etc., will come and go, but the data will always be there. So this data centricity concept shifts the focus from containers for data and specific applications to data that we typically write because we have to answer a certain question or set of questions to the data itself. So data is recognized as the core asset here. It's independent of any architecture or application, and it can be reused by a broad range of stakeholders over time. That's really the point, is that reuse. So there's a link to an article there that's worth reading, and hopefully we'll have these presentations available for people so they can read some of this material. Data centricity refers to a focus, not a physical location. So sometimes people get a little confused about that centricity. It doesn't mean centralizing data in one place. And in fact, it sometimes means the opposite. So data meshes, for example, are a way of decentralizing data, which is a good thing. So just keep in mind that when we talk about data centricity, we're not talking about physical location. We're talking about a focus for ourselves in our relationship to data. And it is, as all things that look like organizational change, a cultural phenomenon. This is a mindset change. And so one of the things that I wanted to make clear when I started speaking was this is a different way of looking at things. And it takes some time in thinking about it and reading about it to really get into a mode where you're thinking in a data-centric way and not an application-specific sort of way. So the next time you start a new project, if you find yourself thinking about a database first, stop doing that, right? And remember this talk and think about some of the things we're saying here and step back and look at the data first and what they are and what they're meant to do, and then worry about the other things. One of the things that can help you take a data-centric approach to things is FAIR. And many of you have probably heard about FAIR. FAIR is an acronym. It stands for findable, accessible, interoperable, and reusable. And I'm just going to describe in general terms what some of those things mean so that everybody has a good feel for it. And then we'll proceed from there. So findable does not mean that the data are just all sitting in one data lake. It can be handy sometimes if you're looking for data and they just happen to all be in the same place, but that's not what findable really means. So findable here means that there are proper identifiers associated with the entities in your data. Those data are described with rich metadata that also use those identifiers. And that data is there for describing the data that you're actually looking for. And often it can mean that you want to describe data in a DCAT standard data catalog. So there are other things associated with findability, but those are some key ones. Accessibility is about making sure that data and metadata are retrievable by those identifiers using a standardized communications protocol. So one of the things I mentioned about GrouPREs was that resolvability part means that the identifiers tend to look like a URI of some kind. And that means that there's a standardized communications protocol that lets your machine get the data as well as you can, which is a good thing. Accessibility is also about metadata persistence. In fact, the FAIR principles suggest that even if your data are gone, the metadata should remain. You should maintain the metadata over time, even if you move the data somewhere else. Like you might move sequencing data, raw sequencing data, to a giant repository that you're not going to look at for a while because you don't need to. But the metadata that you've gotten from that raw sequencing data, you want to have around so you can query it and understand what happened in those sequencing runs. Other things are important in accessibility as well. One thing to keep in mind is early on in the FAIR principles, we wanted the data to be, some people interpreted FAIR as, oh, you have to have your data open for everyone. Not the case. Your data should be as closed as necessary, but as open as possible. And that's it. It's up to you. It's your decision. Interoperability is super key for FAIR and probably the most difficult part of FAIR. And in general, what that looks like is data and metadata formats and vocabularies that are themselves FAIR. That's what you want to have common published standards for representing these kinds of things. Sometimes that looks like semantic web stack things like RDF or OWL or something like that, but it's important to know that FAIR is not a set of standards, and it doesn't even it doesn't force you to do anything in any particular way. It's just recommendations about how you should treat data. The ultimate goal of all this is reusability by humans and machines. FAIR is all about the R part of FAIR. So that's the important thing to keep in mind. Reusability in this case just means my data should be useful for what I put them together for in the first place, but they should also be useful with minimal intervention for any other thing that I want to do with them, even if I haven't thought of it yet. So that's all reusability is about, but it's the most important thing about FAIR. Again, the FAIR guiding principles are just guiding principles. There are no standards. There's no top-down requirement for anything that you have to do with FAIR. And really importantly, FAIR is a spectrum. It's not an all or nothing thing. So there's a concept out there in the community called fair enough. And you should think about how fair your data need to be with respect to findability and interoperability, etc., to get your work done and satisfy that reusability requirement for your own organization. But to make things 100% fair is really, really hard and really expensive, and maybe not even a goal you should set for yourself. So that's kind of it. So really, the FAIR principles are just meant to guide your implementation decisions so that you can use your data as that central corporate asset and reuse it for anything you need to down the line. Typically, what we do with this is try to make sure that our platforms, like I said, at the end of the day, the data have to live somewhere. So really, in terms of these platforms, we take an approach that looks like making sure that our customers or whoever the users are going to be of systems have a good experience with the way they're working with things. Again, this is a cultural issue. So transforming the organization in terms of change management is really critical. Everybody on the IT side and the domain side and upper management has to understand what's going on with respect to data and work with it that way. This is a team sport. Everybody needs to be involved with data and make sure that that it's working the way it needs to for the organization. It requires modern data architecture for many reasons. If you're being better with data, you have to support it with better technology, that's for sure. So that's that bit. So just a little bit more here. One of the things that we find really interesting in this space is a data mesh. It turns out that monolithic applications are very, very problematic for a bunch of reasons. So we are advocating lately data mesh architectures that kind of let you have domain-driven repositories of data. If I'm in a life sciences research organization and I have a lot of different activities going on, maybe that look like proteomics or DNA sequencing, or there are just a 100 different things you can think of. I want to make sure that the data model I'm using for a particular repository, let's say it's proteomics, is understandable by the people in proteomics. So the researchers can understand the data model that's being used for their own data, and they can contribute to it. And the only way to really do that is to keep those data models nice and tight and associated with the people who are using it. And it helps IT because that's a smaller, more manageable repository. And then the emphasis gets placed on interoperability and reusability. So make your repository about proteomics, but make sure your identifiers and your ontologies and those kinds of things are reusable across the organization and understandable when other parts of the organization need to use that. That has to do with the semantic modeling stuff that we also want to take care of. And then fair data, obviously, is another thing that we are working on. So many of our customers are interested in fair data and understanding what fair means for their organization. So that's been an important part of what we're doing lately. And with that, I will turn it over to my colleague, Pilip.
Yep. Hi, everyone. I suppose we have a question, Daria. Are we going to answer that question right now or going to push it to the end?
I think you're going to address that question in your talk, so we may get back to it. But for Ted, you probably haven't seen the question that came in.
I can't see them. Yeah.
Okay.
Oh, good. I'll read it to you. So how hard is it to implement data-centricity at full scale? We're pretty sure there are lots of constraints on the customer end to have it implemented partially only. And can you share some good examples of what this means and what this looks like? And I know, Philip, you're going to cover that a bit, but I think, Ted, you also started to address this, that there's a large change management effort that needs to take place. But would you like to touch upon that, and then we'll turn it over to Philip?
Andrea, Ted, let me jump in. Just a reminder that we have gifts for the questions, and the best question will be nominated. So this question was asked in anonymous mode, so please uncover your name if you want to be considered for these gifts. And yeah, guys, this is a reminder. We still have some time, so please put your questions, and
thank you, Daria.
We will try to answer them. Yeah.
Okay, thanks. Yeah, that's a great question. So I hope someone wins a prize for it. So yeah, I did mention change management, and that's an issue, right? Like the biggest killer of anything that looks like a knowledge management issue gets murdered by change management. So it's really important for the culture to be set for what we're doing here. That's one part of it. The other part of it is how do you actually do this? And the first thing to think about in this space is it requires people, and all of this can be pretty hard. And the reason why it's hard is because the people who do this kind of thing have to be trilingual, and at least some of them do. And what I mean by trilingual is they have to understand some computer science and software development, right? So that they have to have that kind of strong IT background, so they know how a computer will perform when it's dealing with something like a graph, for example. So that's important. The second thing that is necessary is some domain expertise. And the reason for that is because if you're going to make your data interoperable and ultimately reusable across the organization, you will want to develop things that look like standardized ontologies. Those standardized ontologies represent data models that can be used and reused across the organization, and they kind of live in the abstract. That's the kind of thing that lets you model your data independent of any particular architecture. So, so in order to build, that's the second area of expertise, actually, which is that thing that is not IT and it's not domain expertise. It's more like philosophy, and
So,
you have to have that. And then the last part, last part is just domain expertise. Like, you don't get to build an ontology that understands the distinction between a gene and a protein if you don't know what genes and proteins are. So that's,
sure thing. And I know we have to turn it over to Philip. I'll just add to that where I've seen people sort of rally around data centricity is when you can make a business use case for it that spans across different domains. So I brought up real world data before. I've started to see people kind of orient themselves around this notion of data centricity because there isn't any division within the life sciences organization that does not use real world data insights in some way, shape, or form. But the problem that we've seen is we have different silos purchasing this data repeatedly. They're redundant purchases. There's different versions of the truth, even though it comes from the same place. And so that's where I've started to see people kind of get they can wrap their minds around this notion of data centricity. When we talk about the kind of data that everybody uses, it naturally breaks down the silos, and then from there you can start to build a larger organizational mindset around data centricity. So that's where I've seen the kind of messages land. So I hope that helped. But Philip, I know that we are over time, and we wanted to get to you as well.
Yeah. Okay, I'll do my part as quick as possible. So actually, it's also answering that question partially. Here we are talking about the architecture implementations of a data-centric platform, and the most significant architecture implementation is going to be the all-time evolving platform, as it was said, as we are concentrated on the data, not on applications. But there are some other specifics around building such kind of a platforms. And here you may see like just a schematic view of such kind of a platform with the data silos on top of the platform, with the data in the center and operational stuff around that data, which are actually our applications in the platform, and value provided by the platform on the bottom, which may be provided on a different level, like data products, solutions, which will use the platform as a data product itself, or teams, which may use the platform as a set of the solutions. And embracing a data-centric platform requires a cultural shift within organizations. First of all, they must pivot towards a mindset where data management is not byproduct, but at the forefront of their business strategies. And data longevity is crucial as well. Data-centric platforms ensures that data persists beyond the lifespan of individual applications or infrastructure, enabling a legacy of knowledge and foundation for future innovations. So that means that we should concentrate on the business value, not on the applications themselves. And the approach also tackles the common hurdle of data silos. By adopting a data federation approach, the platform will be able to eliminate those silos, allowing the seamless data integration across various domains. And central to the platform is also domain knowledge, as it was said before by Ted, which is encapsulated within a unified data model. And ontologies play a crucial role here, providing a structured and semantic framework, which enhances data understanding and usability, while it requires expertise of building that ontologies, and also takes time evolving that ontologies for your particular business case or business domain. And to support this, you need to have a flexible and evolving infrastructure, actually. And this infrastructure is not about storing data, but about creating an ecosystem which adapts and grows, constantly optimized to serve the data and its related processes. So everything should be built around the data, and the only stone or mountain here is going to be the data itself. And finally, there should be priority on information rather than data. It's not enough to just store the data. We need to extract meaning, understand the context, and transform this data into actionable insights. So that's actually the main goal of the data, which is going to be which is going to serve for. Next slide, please. Okay, and here, building on the foundation of the data-centric platform, we may delve into the tangible payoffs of this model delivers, both technically and organizationally. And from the technical perspective, the platform excels for AI and ML training because it will provide rich, structured, and semantic data environment conducive to developing sophisticated algorithms and models, and offers ready-to-use knowledge, which is particularly advantageous for large language models and automation, streamlining the path from the data to decision-making. And furthermore, there are remarkable ease of consolidation with external information, enhancing outcomes from AI and analytics. And this integration is the key to staying at the forefront of innovation, allowing us to leverage data from diverse sources to generate deeper insights. And on the organizational side, there are substantial benefits as well. The digitization of subject matter expert knowledge is not only curated and validated, but made it visible and retainable in automated way. So you will not depend on your people after they will leave your company or leave that knowledge area. And this knowledge becomes a living asset within an organization, continuously growing and improving. Access to this consolidated knowledge is made easier, not just for personals within the organization, but also for the third-party systems, whether it's search recommendations or reporting. That platform will ensure that the right information is accessible where and then it's needed. And that leads to accelerated research and fosters better collaboration and innovation across the teams and disciplines by breaking down the barriers to information access that enable a more dynamic or synergetic workflow. And also, we need to talk about regulatory compliance, which may be built into the metadata level of your data platform. And it's not only ensures adherence to standards and laws, but also simplifies the compliance process, allowing organizations to focus on innovations rather than on administration of applications and data. And in sum, that's not just about managing data, it's about unlocking its full potential. It's about transforming data into asset which drives growth, fosters innovations, and creates sustainable competitive advantage. Let's go to the next slide. And on the next slide, you'll see the challenges you may face with implementing that platforms. That's why I said that it's all-time evolving process. You are not able to build the platform at once, and these challenges sometimes are really wide-scaled ones. And the journey towards a data-centric approach comes with its own things on a technical front. For example, a primary issue is lack of standardization, as it was provided already by Andrea. We often encounter a fragmented data, a lack of semantics, data architectures built for the specific purposes rather than flexible use, and that lead to significant distribution efforts at a data level, which can be resource intensive. So here you will pay for ineffective ETLs and APIs, as it was said by Ted. Furthermore, there is a lack of IT expertise, which was already covered previously, and that requires skills and knowledge which are currently scarce. Organizationally, there are cultural and structural inertia. So changing the way an organization thinks about how it's handled data is not just a matter of changing system, but also mindsets and organizational structures. It probably will require building new divisions in your IT department or new orchestration committees who will be responsible for the standardization and data-centric approach itself. And legal and ethical barriers also pose significant challenges. Issues such as unclear consent on the data reuse and sharing and various regulatory requirements across jurisdictions complicate the landscape itself. Moreover, they are often constrained by cost structure which is built around applications rather than data itself, that can lead to suboptimal investment decisions and hinder our ability to pivot towards a data-centric model. So you need to think about how to align your data with the cost model rather than aligning your applications with your cost model. And lastly, we must consider the return of investment for legacy tools, because many organizations already made significant investments in their existing technologies, and the transition to new data-centric systems need to make financial sense. So retiring everything is not actually the good way of doing your business, because that will provide you with a really significant financial outcomes without a lot of value provided in the short term. And embracing the data-centric approach will require us to rethink our cost structure and investment strategies, focusing on a long-term value rather than short-term costs. So in conclusion, I maybe say that while the path forward is complex, the rewards promise to be substantial. By confronting these challenges with a determination and strategic planning, we can pave the way for the data-driven future, which is not only more efficient and effective, but also much more adaptable to the ever-changing landscape of the digital age. And that's all from my side, guys.
Thank you very much, Pilip. Thank you very much, Andrea and Ted. That was really interesting. So we have one more question, and if it's possible, let's try to answer them like short.
The question. So I think the question is, how does a de-identified real-world evidence data, which is tokenized, siloed by design, align to FAIR? So that's an excellent question. We have a lot. I mean, that's a talk unto itself. So I would say you're absolutely right that within the life sciences industry, that data is anonymized, but that doesn't mean that we can't provide standards across the organization to use the data, to recognize some of the entities within that data, and also to properly catalog. So when we have a new indication or a new launch, you know whether you already have that kind of data in your domain. Now, we talked about the personalized medicine approach, and we're starting to see with things like CAR T therapy, some of that data now to be able to provide services to patients, it isn't going to be blinded anymore, because those are direct consumers of your product. And in that case, that data needs to be presented in a way that the healthcare systems can actually receive it too. So that's where you start to have some of that FHIR interoperability. But I'd love to talk about this more. Ted, I see you're nodding your head. I think this is a discussion unto itself. So I know we're at time. Please feel
probably
free to
it's a
reach out
good
directly.
candidate for our next conference. Let's
Please
put it on this.
Please feel free to reach out to me directly, and we'll talk. Thank you.
Thank you. Okay, so we prepared a video about the data science at EPAM. Let's watch it and return to the room for the next topic. Thank you, guys, for a great presentation.
Thank you.
Thank you.
Hi, my name is Dmitry Leskovsky, and I'm responsible for growth and development of data analytics branch in Ukraine, where data science, machine learning, and AI take the spotlight. It's a great honor for me to be part of Autumn Data Conference 2023. Here at EPAM, we contribute a lot in people's development, their upskilling into cutting-edge technologies to empower data science, machine learning, and AI capabilities. Throughout the conference day, you may realize the true transformative power of data science and AI. Ukrainian team of data scientists and ML engineers organically complement our global team, 400 enthusiastic professionals. Our customers highly valued our expertise, dedication, and diligence. We crafted more than 10 unique educational programs for our people to become better in the field of data science and AI. For our customers, we developed more than 20 AI enablement programs to respond to their needs way faster. I'd like to thank you for attending our conference today, and let's harness the world of data together.
Hi everyone. Again, yeah, we are starting our another topic, and our next industry that will be under our microscope today is automotive. As you remember, we already touched slightly this topic during the in the speech of the first speaker. We discussed the productivity and the tools, and now we will go even deeper and we'll try to understand together the high impact areas in automotive industry that may be significantly changed with AI tools. And I'm pleased to introduce our next speakers, Brian and Martin. Please welcome.
Hi there. Good morning, good afternoon, good evening. All right. Thank you very much, Daria, for the introduction. My name is Martin Lopatka, Director of Data Analytics Consulting in EPAM Canada. And my colleague here, Brian, will be joining me for this. Brian, did you want to introduce yourself?
Yeah, Brian Matakis. I'm a leader in our digital engagement solution practice across the U.S. Midwest and Mid-Atlantic regions, as well as our North American vertical on automotive.
Amazing. Brian and I have worked together on quite a few different projects, hopefully harmonizing and blending the experience with AI and data layer to, and today we wanted to present a bit of a point of view on what we think are the most exciting opportunity areas within the automotive industry. I would say characterize it a little bit more of a telescope than a radar. So our hope is not to dig too deep on any specific area, but rather paint a picture of all of the exciting things that are happening within automotive that may be potentially immediate or short-term investment areas for AI, where we think very new and very cool emerging experiences might be the next trend. So spots to watch and places to play if you are an AI ML technology developer as well as an experience designer. I wanted to also acknowledge the contributions from Mikhail, who unfortunately couldn't join us as a speaker, but put a huge amount of work into preparing this presentation, as well as all of the underlying sort of research that went into the material we're going to present today.
Thanks, Martin. You know, just to set the scene a little bit and look at the big picture, it's important, especially in this climate where the temptation to do something, anything, is almost irresistible. It's worth having a bit of a disclaimer that and reminding all of us that a strong AI strategy is really going to ensure the greatest impact. And for organizations, it's really important that they first take the step to articulate and align on the areas of the business that can be improved with AI. That's the hard part. We're going to focus today on that enterprise impact. And what we want to really hone in on are some of those most promising areas and there's really 4 areas that for any business, and we'll certainly apply this through the lens of automotive, on really the promise and the impact of what AI can deliver. For some organizations, it's about speed and the automations that lead to it. For others, it's about improving growth and scalability. For others, it's that assistive decision-making, providing users with more guidance and information to reach better decisions. And then finally, it's finally realizing the promise of hyper-personalization, really engaging with customers in that individually tailored way through brand experiences and other content. So just to think about evaluating and developing that strategy, first gathering more information is a good initial step.
Awesome. And just taking a full zoom out, the automotive industry is incredibly complex and multifaceted. Now, I don't expect folks to read the slide that we're sort of showing here, but we're going to come back to this, referring sort of the interconnectedness and sheer scale and complexity of what the automotive value chain sort of has to offer in terms of an opportunity landscape. We definitely aren't going to touch on all of these, but we've picked out sort of the areas at the intersection of opportunity space and the current technological trends, as well as what's most rapidly evolving within this space as places where specific AI applications can move the needle today and in the short-term future. So digging right in on that, we identified four trends, sort of interconnected trends throughout that value chain that offer not only exciting individual opportunities, but also the potential for compounding effects in terms of the way that AI can impact that. This is driven a little bit by market dynamics that are changing. So these are some of the key areas of rapid change. One being consumer experiences and the expectations around the consumer experience throughout the life cycle of vehicle ownership. So from communication, purchasing, marketing, through to the actual vehicle itself, and the post-purchase service period, expectations are changing in terms of what that should be like, moving towards a much more digital experience, a much more connected and holistic experience. That in turn, we see driving a lot of demand and a lot of innovation in terms of the design of vehicles themselves. So software-defined vehicles becoming largely the norm, largely the expectation around what a modern vehicle in 2023, 2024 should look and behave like, and the kinds of functionality that are expected from what a vehicle does. Both of these factors, as well as the constantly evolving global geopolitical landscape, are having profound effects on pushing the supply chain and manufacturing processes into absolutely new territory. We're going to talk a lot about the impacts of the drive for EV, so electric vehicles, as a huge market changer, and how that impacts supply and demand, well, both supply and demand, as well as the manufacturing to meet those dynamics, and in turn, how these factors are leading to a complete transformation in terms of a lot of the business models that have been in place and operating functionally from an ICE automotive landscape for decades at this point. All this to say, these are four key areas that we think are where you can look for really exciting opportunities to apply AI, because the automotive industry is so complex, global, and very and multifaceted in terms of the different application opportunities. There's also an opportunity to see compounding effects from investments of applying AI and generative AI within this space. So I want to start. I guess we had jokingly referred to the different components of this talk around sort of the metal, the market, and the driver. And so I want to sort of stick a little bit with that flow and start out with opportunities specifically and observations within the marketing and supply chain portion of the automotive industry. We see key trends around specifically vehicles increasingly becoming software-defined products. And here it's largely part of the vehicle experience and the larger connected ecosystem outside the vehicle. And so software as an extension of the vehicle itself means that software is becoming largely part of the supply chain itself. So including third-party packages, the integrity and availability of those tools, and then what responsibility ends up on OEM manufacturers and vehicle manufacturers to develop in-house. Consumer demands, as I mentioned, are driving this force. So we are expecting things like voice-assistive interactions within vehicles. Obviously, another key area that folks are very excited to see when you think about AI in automotive is autonomous driving and driver assistive applications. These are things that absolutely are expected to be at a higher bar in terms of performance in order to bring into market. And so the burden in terms of testing that is required in order to bring these does add a layer of complexity to the manufacturing process as well. So again, want to emphasize that software-defined products is not only about connectivity, it's also about functionality. Beyond autonomous and assistive driving, but what is the opportunities for AI to contribute in terms of intelligent experiences, functional experiences that define the actual vehicle itself and the vehicle's behavior as profoundly as the mechanical components, and then the impacts of that on the supply chain, which now has to include things like a software, like a SDLC into the manufacturing process and the software as part of the supply chain. The second major trend that we observe in terms of specifically supply chain and manufacturing is that incredible growth and enthusiasm for the electric vehicle market. This has impacted sort of in a lot of ways, and I think that what we see here, beyond anything else that we can identify at this stage, is that it's driving change. It's driving a change in all aspects of the manufacturing manufacturing process for these vehicles and the underlying business models. So purely from a cost and margin perspective, for electric vehicles, battery manufacturing has been a massive disruptor. It's the most expensive piece of modern electric vehicle, and it's opened the door for upstream supply of battery manufacturers and the entire industry to basically seek out the constituent materials required to produce batteries at the scale and at the speed required to drive the insatiable sort of appetite of the EV market. So we see an evolution in terms of what's the upstream portion of the manufacturing supply chain to drive EV as it continues to eat up the market share. The other interesting piece, apologies, is that opened the door for a diversification in terms of the supplier landscape. So not only specifically to EVs, but the entrance of new business models and new manufacturing strategies. For example, these very vertically integrated brands that are establishing a new relationship or a new sort of nature between the entire value chain and the sales stream and the manufacturing process, taking more manufacturing distribution responsibility to the manufacturer rather than a very, very well integrated and horizontally scalable model. So interesting changes there, and definitely creates an opportunity for different sort of touch points in terms of value chain optimization, supply chain optimization, and a new sort of evolving brand between direct brands and the consumer, where previously a slightly more tiered model might have existed. The third major trend that we see driven within this space is within the subset of electric vehicles, a reliance on public infrastructure. And here, this is different from jurisdiction to jurisdiction, but having the fuel source for electric vehicles rely on a much more highly regulated public electric energy grid infrastructure is creating a lot of opportunity for investment in terms of both infrastructure development and relationships between automotive manufacturers and energy, like traditional energy and electric companies, in terms of making that work. We see investment in this space from private parties, things like housing developers, things like traditional oil and gas energy companies making a move to offer charging stations within their spaces. But the impact is also on the other side of the market. So the availability of charging infrastructure also acts as a market demand sort of dampening force. So folks are looking at the possibility and the ease of vehicle ownership as a main factor as to how EV sales are going to fare within a particular market. So this new sort of evolving relationship between public infrastructure and the vehicle is, I think, part of the story where we're looking more and more at the intersection between the vehicle and the connectivity and integration of that vehicle within the infrastructure, within like a larger digital and electric ecosystem. Potentially, there's even sort of the beginnings of future sort of evolutions around the concept of vehicle ownership themselves and fleet sort of business models that scale to sort of work more effectively with tighter manufacturing margins. And that's, I think, a further out trend that we may see some some potential for interesting future developments. So as I mentioned before, looking at where AI within the scope of these can have an effect at different stages of this total value chain that may in the end lead to compounding impacts, we do see the opportunity, one, for obviously demand forecasting and market analysis. Predictive models to look at demand now have to take into account much more complexity in order to meet the pressure of closer to meet the sort of the pressure of a growing demand and a backlog in terms of manufacturing. Will definitely need to get better predictive models that operate more granularly. They're higher performance in terms of their predictive accuracy, and be able to do things like preempt service offerings, redistribute inventory more dynamically within smaller regions, take into account new data sources like the availability of charging infrastructure in order to get a much more fine-grained understanding of market demand and market segmentation, so that vehicles can be effectively delivered to the appropriate end owners. We also see the opportunity to integrate AI, and specifically generative AI, within catching up on that software testing automation as we see the increased prevalence of software integrated within vehicles and software and vehicles defined by the software that drives their functionality. Optimization methodologies can definitely be applied to help with figuring out the infrastructure and specifically like the appropriate infrastructure investment that might be appropriate for private entities within the automotive space, as well as looking again at that market demand based on factors that are outside of the control of manufacturers. And manufacturing process has a lot of room left for optimization. This has been a domain of AI since AI, and it continues to be absolutely relevant today. I want to speak a little bit about the second major sort of trend area, so consumer dynamics and interactions. And I had started very early on with a statement around personalization, and Brian mentioned it as well. Client expectations are changing, but they're changing more quickly. And this is driving a really, really strong demand. What we've seen now is within other experiences outside automotive, but just in general, interactions with financial institutions, interactions with governments, interactions with any sort of commoditized or commodity service platform. Personalization is the new gold standards, the North Star that everyone in every consumer-facing industry is striving for, and it's coming very quickly. We do see a lot of enthusiasm for this specifically within generative AI. It's impossible to sort of ignore that, and it does require information. It needs to be scalable. The scalability of personalized communication under a model where individual human beings are required to foster those relationships in the way that it's been going will simply not keep pace. And so the ability to get it right, to have scalable, personalized, and contextual communication that is effective is going to be a major differentiator in automotive and in other industries. I like the anecdote that emerged from one of the previous projects that Brian and I had worked on together. This consumer relationship and the ability to engage in consumers goes way beyond just the transactional period, and the kind of like to really capture that you only spend 1%, 0.01% or so, obviously buying the vehicle, but the rest of your interaction with that is owning it. And what that ownership period means does include perpetual and continuous multi-touch point communication process with the vehicle brand, let's say, as a vacuous entity. We see a shifting change in the proposition that dealerships can value. I would posit, despite a lot of turbulence in terms of the value proposition that dealerships have, that they continue to play a critical role in two major parts of the automotive value chain. So one, purely from a logistics and supply chain perspective, the market can be very bursty. We see supply chain disruptions like that draw attention to just how fragile it is. For example, the chip shortage that we recently saw within, I think, all global markets, really drawing attention to the need for some kind of a buffer to smooth out and make sure that a vehicle inventory that's ready for consumer continues to be maintained somewhere. Not saying that vehicle dealerships are uniquely positioned to this, but they've definitely played a prominent role in making sure that there's a smoothing function available, both in terms of the financial sort of burstiness inherent to the automotive industry, as well as being able to accommodate impacts to things like supply chain shortage, shifts in consumer demand. The other sort of evolution in terms of what dealerships may start to sort of emerge in terms of these very, very valuable, let's say, first-party data assets that we're going to require to drive the next generation of performant predictive models. This requires really, really local, specific, regional market data to get right. And that's an oversight that I think dealerships are already positioned and already sort of adept at developing. But leveraging that in a meaningful and globally sort of distributed way is still a lot of room to be had. So coming back to sort of where and what particular AI applications we see being able to contribute strongly within this part of the value chain, once again, we see the need for great predictive modeling, but again, now leveraging regional and specific data to global efficacy. So to have effective global outcomes that can imply or inform upstream supply chain and strategic decision making in that way that Brian was speaking at the top of the presentation. Personalized content generation at scale is one of the areas where we see a absolute enthusiasm, and I would say a justified enthusiasm for generative AI as an application. Being able to get that right is a race that almost everyone in every consumer industry is currently engaged in, and automotive is a prime candidate for where we could see that these first-party data assets that right now live at dealership touchpoints can continue to play a role in that race and evolving these like really exciting AI-powered experiences that have a place within the human-human communication chain. I'd already mentioned local trends and opportunities. Again, can't emphasize enough that like regional data is going to become much, much more important in terms of getting performant predictive and market predictive models. And this piece around the continuous and contextual communication, not just up to a sale, but in and around the entire vehicle ownership lifecycle and what that means for an evolving sort of community around vehicle ownership, which we're already seeing very, very tightly tied to the concept of a vehicle brand. So throughout sort of identifying what are these key impact areas that we think are exciting for specifically AI and the impact of AI, we kind of came around this sort of reflection around what does vehicle ownership even mean in 2024 and 2025 and beyond, and how do we expect AI to affect that experience?
Yeah, you really can't answer that question without thinking about the landscape, and a lot of the thinking we're doing around AI and the application of it is really through a human-centered lens, and thinking about those human connections, whether they're with consumers or whether they're with workers. But ultimately, when we think about the landscape as a whole, taking human-centered design principles and marrying that with our approach to AI is really about creating intelligent experiences. And ultimately, when we create intelligent experiences, they're going to be more valuable. When we think about that spectrum of what exists today, Martin talked about personalization and the promise of it. It's been a promise we've been reaching toward for some time now. And when we think about what AI can do, there's some fear and loathing early on with AI around the autonomous aspects of it that can feel a little scary. Probably where we are today is in the middle of the spectrum, right? We're in the realm of good guesses that are really exciting. They're creating a lot of optimism and a lot of excitement around what AI can deliver and mean. And when we think about really where the path that we're reaching toward is that realm of assistive AI, that's where some of the most interesting solutions can be found when we think about the future and really helping folks make better decisions based on those specific needs. Really, really exciting to think about in terms of that future. And really, when we think about adapting to change, very, very important element. If we go to the next slide, as we think about bringing all these things together, and it's really interesting the way in which experience and data engage and the intersection of those two disciplines has really changed in ways that haven't been available before. And we kind of refer to that as at least our relationship is sort of human-centered design plus, when we think about really bringing together the right AI strategy and then harnessing the power of foundational tech, enabling better decision-making through data, meeting the needs of the business, and making sure that we have human-centered experiences. That really is where the most remarkable and impactful decisions and capabilities and use cases can be found. Put another layer on it. We're thinking and believing that the intersection of human-centered design and AI can really create a distinctive way forward in making AI part of the digital experience that is really about thinking about user expectations and with the way that we predict, support, and respond to users in real time. Now, what we mean by that is it kind of starts from the bottom up. We've always wanted, and the promise of big data, harnessing those foundational capabilities where we can leverage and bring together all of those disparate data sources, where we can have more information and insight in real time, so we can capture those expectations. And then ultimately, the data that we have that allows us to drive more targeted and personalized and assistive experiences allows to have where AI can have greater levels of prediction. And those predictions ultimately can inform experiences that really get to that assistive level of impact, where we think about bringing more data back to the system and ultimately creating the kind of loyalty and impact that's going to create real change over time. So this is kind of an interesting area for Martin and I think we hope that it's a stimulating one, where we've taken a few just imagine instances and use cases, and we'll go through each of these, but they're pretty powerful and hopefully provide a more vivid way to understand how AI can change the way business is done at an enterprise level within automotive. So the first one is, imagine a future where your organization has more power to make informed decisions, where you can make all those connections, and really the only thing left is for users to take action. So let's go to the next slide, and this is an example, a really powerful enterprise example of assistive AI. Imagine equipping data science teams with a new high-speed ability to examine the topics and sources and sentiment and keywords, and ultimately the geographies and demographics that are shaping the sort of consumer research, independent consumer research that ultimately can create a correlation in drops to pre-orders, perhaps pinpoint product issues that enterprises can investigate more quickly. This is the type of aggregation and presentation of information and insight that can make an incredible difference for organizations in the speed with which they operate, but also the insight and information that they can apply toward key decisions. Martin, anything you want to add on this one?
The sort of data layer that we imagine driving this kind of experience is, something that we thought through in terms of basically solutioning out what this could look like. And while on the surface, it looks like a really, really profoundly powerful advanced analytics dashboard, each of the individual components has the opportunity, or like by design, is sort of leveraging some of the technologies that I spoke about earlier. So from the data aggregation, using mechanisms like social listening to preemptively get signals that might be informative before manufacturers and service different points in the distribution automotive sector see that signal. People are speaking about it in an increasingly connected, increasingly social, and here I mean social media, socially interacted society. We have the opportunity to get those insights, to predict those insights a lot earlier, and to be able to act on them a lot earlier. Likewise, that has to be done. That has to be done intelligently. I think the old adage of garbage in, garbage out applies very much to cases like this. So there's still some sophistication that can be evolved in each of these sort of different components that you see here. But to Brian's point about how HCD Plus should work, creating that feedback loop where letting folks have the opportunity, letting consumers have the opportunity to directly share that information is something that evolves when a trusted relationship exists. So it is an evolving relationship between the experience, the feedback loop, and the feedback loop that facilitates an improvement of that experience. As trust is built, as the system's refined, as new data sources emerge and get integrated in as a sort of ever-living sort of relationship between the brand and the consumer market at large, like at the societal sort of level.
Yeah, it's also a really powerful example of one of the biggest shifts, of course, is the independence and depth with which individual consumers are gathering their own information and insight to inform decisions. And ultimately, those decisions are reflected in pre-orders and reservations for forthcoming models, and how those topics can either inform positively or negatively. Heretofore, there hasn't been a lot of control for automakers to really understand where those topics are bubbling up, but also whether those topics warrant further investigation. So it's a really interesting area. Maybe we go to the next one.
Yeah.
So this one, imagine a future where systems aren't siloed, but rather feeding and growing a shared data set that makes recommendations match to individual needs, behaviors, and goals. This is another powerful use case to leverage first-party data assets. In this case, to do things like deepen loyalty, to even elevate product performance, and to enhance touch points for brand engagement, for the adoption of new services across the entire customer lifecycle. And this is really exciting when you think about the information and insight that exists in disparate sources. We've talked for a long time about the impact and influence of a persistent data layer that can bring new assets forward. The speed and predictability, and also the assistive nature to really guide and inform the substance and the real meaning of the direct relationship between customers and automakers, in this case, by harvesting insights both from their behavior and motivations, as well as with the vehicle itself, can really completely change the examination of really the customer life cycle, and when we think about what the future of lifetime value can mean for an individual brand, particularly through the ownership and repurchase cycle.
I think we've always sort of had the industry has always been fascinated by this idea of like omni-channel, multi-channel sort of relationships. But I think at this moment, in terms of what we're seeing, again, driven both by evolution of customer demand and how we've seen that manifested in the manufacturing change, there is an ongoing push for vehicle customization. So modular designs of vehicles that can be customized sort of upstream at the manufacturing stage, and more aligned with direct-to-consumer type business models or business models of distribution that approach a more like a bigger proximity to consumers. And part of that experience that this sort of relationship really enables is indeed keeping the consumers engaged while they're waiting, while inevitably there's like this sense of ownership of the vehicle upstream of even receiving the vehicle. And again, continuing past that purchase point, past that moment where the vehicle purchase occurs, into that vehicle ownership period beyond. And what does that experience look like in terms of how AI can sort of facilitate and enable a positive experience so that you indeed grow things like brand loyalty and ensure that your customers buy their next vehicle from the same manufacturer.
Great.
I want to move to the last one. Yeah.
Yeah. So this is a really, really powerful example, and again, we've talked a lot about in this talk around hyper personalization, but this idea when we think about every interaction can build data-based profiles that will be used to adapt and personalize future experiences. And if we go to this next example, it's interesting. Our last example we just shared kind of showcased the power of leveraging first-party data assets. And in this instance, we're thinking about hyper-personalization and really the interplay between creating great experiences that rely heavily on knowing customers. And so in many cases, particularly in the early stage areas of relationships, we need to collect data and insight. And in this instance, we recognize that initial shopping and sales funnel can benefit from harvesting user insights, and it needs to be done in a trusting and authentic way, no doubt. But collecting that information and insight can rapidly shape the touch points that ultimately can reflect individual preferences and create this sort of intuitive brand right connections to accelerate purchase. In this case, being able to, through the experience itself, through imagery, through trigger points of content, through the shopping experience and the transparency around it, all of these things are within reach and can really shape and change the relationship that exists today in that early stage, very impersonal, contemporary kind of car buying dynamic that we absolutely want to realize this hyper-personalized future.
And I think to coming back to the very beginning of how does AI impact this experience? Well, one, in terms of that, it has to be scalable. So finding that right balance between scalability and like not losing the personal touch is a challenge. It is something that is going to continue to evolve with the set of AI capabilities that we see emerging now around generative AI. And the other big factor is the consumer shift towards their willingness and interest to sharing that kind of data, to direct data aggregation, being comfortable with it. That only works in a trusted model. It's built, it's prefaced on the assumption that first-party data assets and that a brand trusted relationship exists. And this is a trend that we are seeing emerging with really exciting sort of movements in the regulatory landscape around how AI is regulated, responsible AI, a lot of great movement in terms of data privacy regulations and how they can work. As people solve this from a technology perspective, consumers become more comfortable with data aggregation, more aware of it in the public sphere, and more willing to do that. But they expect a value proposition. Right? Consumers are getting more and more aware of the fact that if data is being aggregated, profiles are being created, they expect to see the upside of that in the experiences that they experience. And so we see this hyper-personalization trend continuing to grow, continuing to play a really impactful role in the full sort of vehicle ownership, what it means to be a vehicle driver moving forward. So coming to the conclusion, I know we covered a lot of ground and we sort of cherry picked different specific subsets or like locations within the total automotive value chain based on sort of where we are most excited. So again, 3 sort of general categories. These are the trends we think are going to be most impactful and most available for very specific impact from AI within the immediate future, so 2023, 2024 and beyond. Increased observation of software-defined connected vehicles, integrated digital experiences, and with that, the need for AI systems to both facilitate the development of that, as well as play a part in the ecosystemic concept of the vehicle with the rest of the digital world. Huge impact from the EV market, absolutely changing the supply chain, so pushing supply chain and manufacturing into new territory, both physically in terms of the constituent pieces that make up a vehicle, as well as the business models and the value and the profitability of all of these different stages. And furthermore, in terms of a new factor that drives market demand. This relationship with infrastructure is rapidly evolving. It's absolutely fascinating and does create a new sort of, I wouldn't say secondary market, but I guess like, again, that ecosystemic piece is what is going to be the role of automotive manufacturers in public infrastructure investment as vehicles are more connected with public infrastructure. Personalized contextual communication is the new North Star. I think we've really emphasized that throughout the presentation, and I would say rightly so. This is not going away. It's only going to accelerate. The enthusiasm and investment across automotive as well as other consumer-facing industries is absolutely immense, and the tooling to start to really create differentiated experiences right now is sort of reached a new sort of threshold with the real like commoditization, I would say, of generative AI tools that we're experiencing today. Likewise, the relationship and the both economically and in terms of the relationship of what the dealership, the brand, and the manufacturers, that trifecta of parties is largely being redefined within the context of all of this rapid change. For enterprise, we really think that assistive AI experiences, so the kinds of AI products, both within the organization and handed down to the user, as well as user here, I mean consumer, as well as mediating that relationship, HCD Plus is a model that we think is going to really yield the best experiences, the most efficient designs, and operational revolution in terms of the way that organizations integrate data through assistive AI products for things like strategic decision making, as well as process optimization. And first-party data assets will continue to play a really powerful role as a differentiator compared to competitors that are not curating the same quality and quantity of those data assets to build out the experiences that I've mentioned in all of the previous points. So with that, I think we are about perfectly on time to move to the Q&A session. Yeah, do we have a moderator? There we go.
Yes, you have. Thank you very much, Brian and Martin, for a great presentation. I checked our questions. So far, we don't have, so I think your coverage of the topic was perfect. Again, thank you so much.
Must be so comprehensive.
Yeah, it was so comprehensive that we don't have any questions. But guys, still we have some time. So if you would like to ask our presenters something, don't waste this opportunity. As you remember, we have some presents, we have some gifts as a nomination for the best question for each stream. So If you want, please use this opportunity. Okay, then, while people are thinking if they still proceed with the questions, I can tell you a couple words what we are doing next. So we finished with our separate stream agenda, and now it will be a time, but don't switch now. It will be a time to return to our main room. The link to the main room, you can those who joined via YouTube, you can find in the description to the stream. And return to the main room. It is called Opening Stream Architecture Roundtable Closing Ceremony, and just press the link. If you are connecting via the VR community, you can find this link in the section of questions and answers. Alexandra Kalmakova just put the link there. So next we will check the, you will go to this room. During the round table, we will also announce our winners in all nominations. We are stopping the quiz now, and the results of the quiz will be announced there, as well as the authors of the most interesting questions. So please don't jump off and go to this room as well with our leadership and the results of the conference. Okay, so I don't see other questions. Then we prepared for you one more interesting video. We will launch it in a minute. And another important announcement is we are asking you to fill in the form with your feedback. This feedback are very valuable for us, as it helps us to make our events more interesting and add for the next conference probably topics of high value for you. So please check the chat, check the same section as I said before, and fill in the form. Also, you will get this notification on your email that you used for the registration. Okay, I think that's all. We can proceed with the video, and then please return to the next to our roundtable. And thank you all for joining, and we will wait you on our next events.
In today's tech and data-driven world with a vast amount of accumulated data, it becomes crucial for enterprises to utilize data effectively and innovate through data. And EPAM is here to support our clients in this journey and offer best solutions. Each of our offerings is a combination of capabilities, a set of experience-based solutions, capacity, a team of cross-functional experts, and finally methodology, varied implementation guides, and templates. We are ready to support our clients end-to-end, from data platform build to modern generative AI capabilities development. Data Factory. Data Factory is a data product-centric framework which consists of 4 pillars: data strategy, data product mindset, data platform, operating model, driven by business and enabled by technology. We have handbook and templates, trainings and accelerators to speed up the delivery process. EPAM Data Landing Zone is an instrumental tool designed to accelerate the management processes of data project infrastructures. Unlock the boundless potential of your business together with us. Contact us on epam.com.